All right, people. I believe all of you are doing great, having a good time. So, welcome to Unacademy NEET English. So, today we have the marathon of units and measurements, or you can also call it the units and dimensions. One of the important chapters when it comes to the NEET physics. Okay, because you can expect 3 to 4 questions from this small chapter. This is a very small chapter. We are going to finish this in 4 to 5 hours. Okay, but this is very important from the weightage perspective because you can expect 3 to 4 questions. Previously, we have been seeing from the past few years that 4 questions they have been asking from this particular chapter. Okay, that's why we consider it one of the most important chapters when it comes to the NEET physics over here. Okay, so my dear friends, let's dive into this particular session. Let's not waste the time, and I would want you guys to smash the like button as soon as possible. If you have not liked the session yet, smash the like button as soon as possible. Okay, and when it comes to this chapter, I will be starting from the scratch, from the basics. If you haven't studied this before, you would be able to understand for sure. That is my guarantee. Okay, now guys, I hope all of the students have joined. Let's start with the session over here. Let's take a look at what we are supposed to study in this particular case. Okay, what we are supposed to study in this particular case. Okay, yes, guys, first and the foremost thing is, let's talk about a physical quantity. Let's discuss what is a physical quantity. Okay, guys, you might have heard a lot of times about this physical quantity, what this physical quantity is all about. So that's what we need to discuss in this particular case. Okay, first thing, let me just tell you, when it comes to a physical quantity, physical quantity, okay, first and the foremost thing, that's what we need to understand over here is a physical quantity. What this physical quantity is all about. Guys, we say in simple words, a quantity that can be measured is called a physical quantity. Okay, I would say simply, a quantity that can be, which can be measured is called a physical quantity. Guys, tell me one thing. When it comes to the quantity which are measurable quantities, like example, we say over here, simple, we say length. Sir, length is a physical quantity which we can measure. Like we say 2 meters, 3 meters, 4 meters. Okay. We say mass. Okay. We say time. Temperature. Okay. We say velocity. Okay. So all of these are the physical quantities. So basically, these are those quantities which are measurable quantities, Simply, we say length is what we can measure. We say mass of this is 2 kgs. So I can say this is a measurable physical quantity. So we say temperature, 25 degrees Celsius. We say velocity, how fast the car is moving. All of these are the physical quantities. Okay. Now guys, let me just tell you over here, in this particular case, then we have the non-physical quantity. What is a non-physical quantity all about? We say simply, in this particular case, when it comes to a non-physical quantity, we say a quantity that cannot be measured is called a non-physical quantity. Okay, it is just the opposite of physical quantity. Just a second. Okay. So we say non-physical quantity is that physical quantity which cannot be measured. Okay. Now, my dear friends, example is sound. Example is light. Okay. Forget about these as of now. Let's talk about goodness. I say the goodness of this particular person is very large. You don't say it has 2 kg of goodness or love. Love is also a non-physical quantity. We do not say I love that person by 2 kg. Okay. Like we have hatred. How much you hate a particular person. I hate him 2 liters, 2 kg. It is wrong. So we say these are those quantities which cannot be measured. This is something which is immeasurable. Okay. As simple as that. And similarly, we say light and sound. You say, sir, we measure the brightness of, we measure the intensity. Intensity of the sound is loudness. Loudness means how louder the sound is. That is a physical quantity. But when it comes to the sound as a whole, it is a non-physical quantity or immeasurable quantity. But intensity of sound means loudness, how louder the sound is, how brighter the light is. That is called the intensity of light. Intensity of light is a physical quantity. Frequency is a physical quantity. But when it comes to a light as a whole, it is a non-physical quantity. Simply, that quantity which we cannot measure is what we call the non-physical quantity. Goodness, love, hatred, sound, light. But when it comes to the intensity of sound and light, that is a physical quantity. I hope this is crystal and clear to each and every single student. Okay. Now, guys, let's move on to the next one. And guys, if you have not liked the session yet, I would want you guys to smash the like button as soon as possible. Okay. Let's take a look at this particular point. Guys, see, when it comes to the physical quantities, okay, measurable quantities, we have divided the physical quantities in 3 different categories. We have divided the physical quantities in 3 different categories. First one is the fundamental quantities. Okay. Then we have the supplementary quantities. And then we have the derived quantities. So physical quantities are divided in fundamental, supplementary, and divided. Now, guys, what are the fundamental physical quantities? We say those physical quantities which are independent from each other, which does not depend upon each other. Okay. Like, let me just give you the example over here. Guys, let me just give you the example over here. We say there are 7 fundamental physical quantities. We say mass, length, time, temperature, amount of substance. We say electric current and luminous intensity. Guys, listen to me very carefully. Let me just give you the feel. Let's suppose if somebody asks you what is velocity. You say, sir, velocity is displacement upon time. Displacement upon time. And what is displacement actually? It is length. And this is time over here. Means this velocity we cannot consider as the fundamental physical quantity. Why? Because this velocity depends upon length. This velocity depends upon time. But fundamental physical quantities are those physical quantities which does not depend upon each other. Okay. So we say length. Length is length. Even you cannot define length. Okay. So we say length does not depend upon time. Time does not depend upon length. But when it comes to this physical quantity, it depends. So that's why we have not put it in the category of fundamental physical quantities. Okay. Now, guys, we say these are the 7 fundamental physical quantities that you guys need to remember. Okay. Like SI unit of length, we measure the length in meters. Okay. We measure the length in meters. We measure the mass in kilograms. We measure the time in seconds, temperature in Kelvin, amount of substance in mole, electric current in ampere, and this is candela. Okay, and this is the symbol that you can exactly see over here. This is the symbol that you can see exactly over here. So these are the fundamental physical quantities which does not depend upon each other. Then, my dear friends, wait for supplementary physical quantities. Let me first define the derived physical quantities. Please tell me in the chats if it is clear till over here. And I would want you guys to smash the like button as soon as possible. Now, guys, listen to me very carefully. Listen to me very carefully. Derived physical quantities. See, guys, when it comes to the derived physical quantities, we say those physical quantities which are derived from fundamental quantities. Like. Guys, area, we have got force, we have got acceleration, we have got work. These are also the physical quantities. These are also the physical quantities. Okay, time multiplied by this time. Okay, so you have in denominator time and time, here you have length. Is this crystalline clear to each and every single student? Tell me, guys, in the chats. Everyone means everyone. What is happening? Is everything Is it fine? Is it fine, guys? Okay, okay, great. Great. Okay, fine. Cool. So this is basically, these are what we call the derived physical quantities. Okay. Now, guys, let's take a look exactly over here. Supplementary physical quantities. We'll have to see this later. As of now, you just remember in this particular case, guys, see. We say, when it comes to the supplementary physical quantities, we say these are also the fundamental, but they do not have the dimensions. Okay, sir, what is this dimension? We'll see it later on. Okay, and only unit, they have only unit. Those quantities, those physical quantities which have only unit but they do not have the dimension. Now if you ask me what is dimension, we'll have to see after some time. So as of now, you just remember the definition. Okay, example over here is angle, solid angle, etc. Over here, that we will see after some time. Okay, now guys, let's talk about the unit. Let's talk about the unit. Understand one thing very carefully. Understand one thing very carefully. See guys, when it comes to the unit, okay, see guys, we say, let's suppose distance is 25 kilometers. Okay, the length of the road is, let's suppose, 25 kilometers. We say this is a straight track. Okay, and its length is 25 kilometers. Okay, now guys, what is this kilometer over here? This kilometer is what we call the unit. Okay, we measure the distance in kilometers. This is a unit. Similarly, you can also say it is distance is equal to 25,000 meters. Okay, so we say this is also a unit. Like, you can measure the distance in kilometers also. You can measure the distance in meters also. This is also the unit. This is also the unit. Okay, now my dear friends, 25,000 gives you the idea that how bigger it is compared to the 1 meters. How bigger it is? 25,000 times 1 meter. It is 25 times 1 kilometer. Okay, now my dear friends, listen to me very carefully. What we are going to understand is system of units. What does system of units actually mean? See. Let's suppose there is a country. This is a country. This is a particular place. Okay, and in here, over here, the people usually measure the distances in, let's suppose, meters. Okay, this is a particular country. The name of this country is, let's suppose, A. And we went to this particular country. We saw that the people are measuring the distance in meters. Okay, and they are measuring the time in seconds. They are measuring the time in seconds. Okay, okay, and we saw that they are measuring, we say, mass in kgs. They are measuring the mass in kgs. Now, my dear friends, in this particular case, we say that this country is following a particular set of units. Like, they measure the length in meters, they measure the time in seconds, they measure the mass in kgs. Okay, they measure the mass in kgs. So we can say they are following M, okay, K and S, MKS system, meter, kg and second. This is what we call the MKS system. Like, similarly, back in time, there was another country over here. Okay, since we can measure the distance in meters also, we can measure the distance in centimeters also. They say we will measure the distance in centimeters. And these people say that we will measure the time in seconds. Okay, they say that we'll measure this in grams. Okay, this in grams. Now, my dear friends, in this particular case, we say this country is following, that is CGS system. CGS system. What is that? Centimeter gram system. So if a group of people, or if a particular country is following the set of system, a particular set like CGS, they measure the distance in centimeters, they measure the time in seconds, and they measure the mass in grams. This is called the CGS system. This is what we call the MKS system. So similarly, back in time, there were a different number of people out there which were following the different system of units. Like, a particular country was following CGS system, that is centimeter gram second. And another one was following FPS system, that is foot pound second. They were measuring the distance in foot. They were measuring the mass in pound. They were measuring the time in second. Similarly, another country was following MKS system, meter kg second. And then finally, we introduced, that is what we call the SI system. Because when people of this country were visiting the people of this country, okay, for the trade purposes, they were having a lot of confusion between each other because they were following CGS system. These people were following, we say, FPS system. So that there was a lot of chaos and confusion. So that's the reason we made the SI system, which every country started following afterwards. Okay, and that is what we call, it is the modified version of MKS system. It is the modified version of MKS system. Now, this became the internationally accepted system. So this country, all the countries in the world started following this particular system, so that there is no chaos, so that there is smooth trade between different nations, between different countries. And that's what we call the SI system. Are you able to understand what is this? Are you able to understand? Please give me the signal in the chats with the fire emojis. Everyone means everyone. And smash the like button if you have not liked the session yet. Tell me, guys, is this crystalline clear to each and every single student? Great. Now guys, units of different physical quantities. Let's write the units of velocity in MKS system. Let's write the unit of velocity in CGS system. Guys, see, we say when it comes to velocity, it is displacement upon time. Guys, understand very carefully. It is displacement upon time. And when it comes to MKS system, we measure the displacement in we can say meters. This is meter, and time in seconds, so it will be meter per second. And here I can say in this particular case, here we measure the distance in centimeters, okay, and time in seconds. So centimeter per second, meter per second. Let's talk about acceleration. Acceleration is velocity upon time. And my dear friends, what is the unit of velocity? That is meter per second. So I'll write meter per second. And time over here is also second into second. So it will become meter per second square. Similarly, if we talk over here, instead of meter, we write over here centimeter upon. And instead of, we say time in this particular case, we can say second square, centimeter per second square. Now guys, let's talk about force. So here, force is equal to mass into acceleration. We measure the mass in kg, over here kgs, okay, this is kg. And we say acceleration, that is meter per second square. So I can say kg meter per second square. And when it comes to this one, here we measure kg in, here we measure mass in grams in this one. So this will be gram, okay. We measure the distance in centimeters. So this will be centimeter per second square. Okay. And then we have the last one over here, that is momentum. Momentum is mass into velocity. And we measure the mass in kgs. And velocity is meter per second. Kg, meter per second. And if we write over here, instead of kg, we write over here grams. Instead of meter, we write over here centimeter, okay, per second. This is how we write the unit of momentum in CGS system. And this is how we write the unit of momentum in MKS system. Let's move on to the next one. Pressure. What is pressure? Guys, pressure is force upon area. Now, my dear friends, I can say in this particular case, what is force? Force, the unit of force in MKS system we recently got, that is kg meter per second square. So I'll just write over here, this will be kg meter per second square. So I'll write it something like this, kg meter per second square. Okay. And then we have area. Area is length into breadth. Guys, area is length into breadth. That is length into length itself. So that will be meter square. For area, it is meter square. Now this and this will cancel. So it will come out to be, that is kg. Okay. Then we say upon kg upon, we can say meter and second square in this particular case. Now, if we write this in CGS system, instead of kg, we have got gram upon. Instead of meter, we have centimeter second square. Work is force multiplied by displacement. What is the unit for force? That is kg. Then we say meter per second square. Okay, per second square. This is force multiplied by displacement. Displacement is over here meter. So you can say this is kg meter square upon second square. Similarly, if we write over here, instead of kg, we write over here gram. Instead of meter, we write centimeter square upon, we write over here second square, because here we take the second also. Then we say density is mass by volume. Mass in this particular case is kg. Okay. And volume is, we say, sir, meter cube. Length into breadth into height is volume. So length into length into length, that is meter cube. And here we can say this is gram. Okay. This is gram. This is gram upon, we can say, centimeter cube, gram centimeter. Guys, give me the signal in the chats if everything is crystal and clear till over here. Okay, if you got the feel of different system of units. If you got the feel of different system of units. Okay. That's great. That's great. That's great. Okay. Cool, 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 cool. Guys, smash the like button if you have not liked the session yet. Now guys, class duration will be 4 to 5 hours. This is a small chapter and I'll be showing you all the tricks, whatever is needed. Convert the momentum of a ball from MKS to CGS system. You have got a ball, you are supposed to convert its momentum from MKS to CGS system. This is the question that is given exactly over here. Guys, see. Let's suppose we have got a ball over here. This is the ball, okay? And I'm saying mass of the ball is, let's suppose, 10 kgs. This is the mass of ball. And it is moving with the velocity 5 meter per second. It is moving with the velocity 5 meter per second. Okay? We have got a ball over here. Its mass is 10 kgs. Velocity is 5 meter per second. Now, let's first find the momentum of the ball. Guys, we say momentum is mass into velocity. Mass into velocity. What is the momentum? What is mass? That is 10 kgs over here. Okay, I'll write 10 kg. And what is velocity over here? That is 5 meter per second. Now tell me, 5 into 10 is, we can say over here, that is 50. So this will be kg meter per second. Tell me, this 50 kg meter per second is the momentum of a ball in which system? This is an MKS system, because in MKS system, we measure the mass in kgs. We measure the distance in meters and time in seconds. This is an MKS system. Now guys, you have to convert this momentum, which is in the MKS system. It is an MKS system. You have to convert this momentum into, we say, CGS system. Guys. I'll just write over here. This is given as 50. And I can say this is kg. This is meter per second. If you want to convert this into, it's a CGS system. Tell me one thing. Don't you think that I can write it something like this? Keep this 50 as it is. Guys, kg, could you please tell me, when it comes to the CGS system, we measure the mass in grams. Okay. Tell me, how many grams is equal to 1 kg? We know that 1000 grams. We know that 1000 grams is equal to 1 kg. Everybody knows that. Okay. And how many centimeters is equal to 1 meter? You will say, sir, 100 centimeters is equal to 1 meter. I can say it something like that. Now, instead of this kg, can I write, sir, this will be 1000 grams. One and the same thing. Either you write 1 kg or you write 1000 grams. Okay. Instead of this meters, can I write over here 100? I can say centimeter in this particular case. Yes. And second, do not change the second, keep it as it is. So I can say upon, we say second over here. Okay. Now tell me, my dear friends, in this particular case, can I say how many zeros? 1, 2, 3, 4, 5 and 6. So I can say this will be simply, that is 5 into 10 raised power 6 gram centimeter. This will be gram and then it is centimeter upon, we say second. This is the value of momentum in MKS system. This is the value of momentum in MKS system. 5 into 10 raised power 6 gram centimeter per second. Simple. Convert this kg into grams. Here, instead of meters, we write centimeters divided by second. That's it. Okay. Next, my dear friends. Let's suppose you have a question something like this. Density is given as 6 kg per meter cube. Okay. Convert into a CGS system. Tell me. Here, this is given into MKS system. We are supposed to convert this into CGS system. Tell me how we are going to do that. Guys. If I write over here a density is given as 6 kg per meter cube. Tell me one thing. Can I not write this as 6? If we have to convert this into kgs, into CGS system, instead of kg, we write grams, and I'll write over here 1000 grams divided by meter cube. Tell me how many centimeters is equal to 1 meter? I can say, sir, in this particular case over here, this will be 100 centimeters. Instead of 1 meter, I'll write 100 centimeter. Since it's cube, I will put the cube over here. Since it's meter cube, I'll put the cube over here. Okay. Now tell me one thing. Can I say in this particular case, guys, this is 10 raised power 2 whole cube. 3 into 2 is 6. This will become 10 raised power 6. So it will be something like this. 6 into 10. This is 1000. I can write 10 raised power 3. This is 1000. And then we say grams upon. In the denominator, it is 10 raised power 2. Guys, it is 10 raised power 2 whole cube. 3 into 2 is 6. So I can say in this particular case, this will be 10 raised power 6. Okay, and this is centimeter cube, because this cube is for centimeter also, this cube is for 100 also. Now 3's, and this is 3 over here. Now this will become 6 into, take this 10 raised power 3 in the numerator, it will become 10 raised power minus 3. And this is gram per centimeter cube. This is the simple technique that I use in every single question, and you get the answer. Please tell me in the chats if everything is crystalline clear. Please tell me in the chats if everything is crystalline clear. Please tell me in the chats if everything is crystalline clear. Great. Similarly, if you have over here the next question, that is convert into MKS system, do the reverse now. Okay. You have 6 gram per centimeter cube, like this question only. Okay. No, it is 6 gram per centimeter cube. You have to convert this into the MKS system. Could you please tell me the answer in the chats? Could you please tell me the answer in the chats in this case? Could you please tell me the answer in the chats in this particular case? 6 gram per centimeter cube. Guys. See. Let me just tell you, if the density is given in this particular case as, I can say 6 gram per centimeter cube. Tell me one thing. What is that? See, when it comes to how many grams is equal to 1 kg? 1000 grams is equal to 1 kg. Okay. Could you please tell me, sir, 1 gram will be equal to what? You will say 1 upon 1000 kgs. Okay. Or you can say it something like this. Guys, this is 10 raised power 3. If you take it in the numerator, so it will become 10 raised power minus 3 kgs. You can say it something like this. 1 gram is equal to 10 raised power minus 3 kgs. Similarly, another one you can remember over here. What is that? Guys, see, we say 100 centimeters is equal to 1 meter. So 1 centimeter will be equals to 1 centimeters will be equals to 1 upon 100. 100 means 10 raised power 2. Okay, this will be meters. So 1 centimeter, I can say simply from now onwards, is equal to 10 raised power minus 2 meters. Guys, remember these conversions from now onwards directly, because in the maximum number of questions, you'll be using these directly. Now tell me, can I write this over here? Guys, this is 6. Instead of 1 gram, can I put 10 raised power minus 3 kgs? Simple, sir. This will be 10 raised power minus 3 kgs over here, because we have to convert grams into kgs. Then I can say over here divided by centimeter cube. How many centimeters is equal to 1 centimeter is equal to how many meters? 10 raised power minus 2. So I can write over here 10 raised power minus 2 meters instead of 1 centimeter, and it is whole cube. Now, can I write this over here? This is 6. This is 10 raised power into 10 raised power minus 3 over here kgs upon. Now tell me, this will be how much? This is 10 raised power minus 6. 3 into 2 minus 6. And then we say meter cube in this particular case. Now guys, 10 raised power 3 and 10 raised power minus 3, 10 raised power minus 3. What will be the answer? 6 into. We can say, guys, it is 6 divided by 10 raised power minus 3, and this is kg per meter cube. Now, if you take this in the numerator, so density will come out to be, that is simply 6 into 10 raised power 3, I can say kg per meter cube. Okay, tell me. Okay, is this clear? Is this clear? Guys, tell me in the chats, is this clear? Is this clear to each and every single student? Smash the like button if you have not liked the session yet. Everyone means everyone. Liking the session is extremely mandatory. Great, 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 great. Now guys, see, guys, this is the simple trick that I use in case of the convergence. Okay, I have shown you some questions when it comes to the convergence because I feel this is one of the easiest tricks, okay, in order to do the convergence. Next, let's move on to this one. Now guys, understand very carefully. First, let me explain this, then I'll show you what are the types of questions which has the probability to come in your NEET examination. Now guys, let's talk over here about dimensions. See guys, when it comes to the dimensions, I can say it gives us an idea how many fundamental quantities are involved in a physical quantity. Guys. Let's suppose I'll take a velocity over here. I'll take an example over here, that is velocity. Let's suppose I'm taking velocity. Guys, understand very carefully. Let's suppose I'm taking velocity. When it comes to the velocity, we say how many quantities are there in velocity? We say velocity is simply displacement upon time. Velocity is simply displacement upon time. Now, what is displacement? Displacement is length. Okay. And then we have time over here. So basically, it is length upon time. Now, my dear friends, tell me one thing. This is length is one fundamental quantity. Time is one fundamental quantity. So instead of this length, I'll write L1 over here. Why? Because only one length is involved in this. Okay. And divided by time in denominator, I'll write T1 over here. Sir, why cannot you mention T2 over here? Because only one time is involved and that too in the denominator. Only one length is involved, that too in the numerator. So I can write this as, if you take this in the numerator, so it'll become L1, we can say T minus 1. Even some people also write it something like this, sir, M0, because no mass is involved. M0, I can say L1 T minus 1. What does it say? M0 means no mass is involved in the velocity. There is no mass term in the velocity. L1 means there is one length in this. And T minus 1 is there is one time in the velocity, that too in the denominator. That's why we got the minus 1 over here. And we say this is the dimensional formula of velocity. This is the dimensional formula of velocity. Okay. This is the dimensional formula of velocity. So dimensions give us an idea how many fundamental quantities are involved in a physical quantity. I hope you got the crystal clear feel of this. How many fundamental quantities are involved in a physical quantity? What is going to tell you? That is dimensions. Okay. Like velocity we already calculated. That is simply LT minus 1 or M0 LT minus 1. Let's talk about acceleration. Guys, tell me one thing. When it comes to acceleration, we say it is velocity upon time. We say it is velocity upon time. Okay. Now, guys, what is the dimensional formula of velocity? We say it is LT minus 1 upon, we can say time over here divided by time. Now, guys, see. Can I say over here, this will be L. This will, when it goes in the numerator, it will become T minus 1. So it will become LT minus 2. Now, when it comes to the acceleration, there is one length involved in acceleration and there are two time involved in the acceleration. That too in the numerator. That's why we got over here T minus 2. Okay. That too in the denominator. Sorry. Okay. Now, let's talk about the force. Guys, when it comes to the force, can I say this is mass into acceleration? Yes. Now, for mass, it is m1, one mass. For acceleration, it is Lt minus 2. This is the dimensional formula of what? That is force. Similarly, when it comes to the work, it is force multiplied by displacement. It is force multiplied by displacement. Now for force, guys, we recently saw it is mLt minus 2. So I can write over here mLt minus 2. And when it comes to the displacement, it is L. Displacement is L. So can I write over here, this will be simply, that is m. L into L becomes L square and T minus 2. T minus 2. Okay. I hope this is crystal clear to each and every single student. Then we have the energy over here. Guys, we have got the energy over here. Guys, what is energy? Take any energy. 1 by 2 mv square, kinetic energy. I can say this is 1 by 2 mv square. Okay. 1 by 2. Guys, when it comes to the pure number, it is dimensionless. It does not have the dimensions. M. So M is M. Mass is mass. Velocity square. What is the dimensional formula of velocity? Lt minus 1. So you can say Lt minus 1 and its square because you have got v square. So it will become m L square. This square is for L also. And then we say over here T minus 2 because this is minus 1 into 2 is T minus 2. Okay. 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 Is this clear? Is this clear? Is this clear? Then you have got the power. What is power? Power is energy upon time. I can say this is energy upon time. Energy upon time. And for energy, I can write this is m L2 T minus 2 upon, we can say time over here, T. So it will become L2 T minus 3. Okay. Okay. I hope there is no confusion left in your mind when it comes to the dimensional formulas over here. So in order to calculate the dimensional formula, you should have the idea of what? You should have the idea of the formula of that particular concept. You'll get the dimensional formula. Next, let's take a look over here. Momentum. Guys, momentum is mass into velocity. For mass, it is m. For velocity, it is Lt minus 1. Angular displacement over here. So remember, when it comes to the angular displacement, it is theta. Angular displacement means theta, angle. Okay, it is dimensionless. Okay, it is dimensionless. So for this, you can write m0, L0, T0. Always remember this. Okay. Angular velocity. Angular velocity is angular displacement upon time. Like we say, velocity is displacement upon time. Similarly, angular velocity is angular displacement upon time. And in this particular case, I can say for theta, it is dimensionless. So it is 1 upon t. So take this t in the numerator, it will become t raised power minus 1. So some people also write it something like this, m0, L0, t minus 1. Angular acceleration, it is angular velocity upon time. That is omega upon time. Okay. Now, omega, for omega, it is t raised power minus 1 because this is omega. This is omega. For time, this is time over here. Take this in the numerator, it will become t raised power minus 2. Then we have frequency. Frequency is inverse of time period. So take this in the numerator, it will become t raised power minus 1. So means this and this has the same dimensional formula? Yes. Different physical quantities can have the same dimensional formula. Now see, let's take a look exactly over here. Physical quantities having same dimensional formula. Those physical quantities which have got the same dimensional formula, that's what we need to understand over here. Okay. Now guys, in this particular case, we say distance. What is distance? Distance is length. 40 meters, 30 meters, 25 meters, something like that. Similarly, displacement. What is displacement? Also length, 20 meter, 30 meter, 40 meter. Whatever is the dimensional formula of this, that is L. For this, it is also L. And then we say radius. Radius is also what? Length, distance. So it has the same dimensional formula L. Okay, light years. Light year is also a distance. So it has also the dimensional formula of L. Okay. Then we say radius of gyration. Also it is a length. So it has same. Focal length. It has also L. Okay. 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 Astronomical unit. Parsec. All of these have got the same dimensional formula L. Then we have speed. Speed is what? How fast the car is moving. Velocity. One and the same thing. Velocity of light. One and the same thing. It is also velocity. Velocity of sound. It is also the values will be different. Forget about the values. I'm talking about the dimensional formula. That will be same. Terminal velocity, average velocity, orbital velocity, escape velocity. All of these have got the same dimensional formula, LT minus 1. LT minus 1. Similarly, acceleration, average acceleration, acceleration due to gravity, intensity of gravitational field, centripetal acceleration, it has got the same dimensional formula, LT minus 2. Impulse, change in momentum, same dimensional formula. Okay, force, weight. Weight is also force. Tension is also force. Thrust is also force. Gravitational force, spring force, electrostatic force, magnetic force, normal reaction, friction. All of these are the different varieties or categories of forces. So they have got the same dimensional formula, MLT minus 2, which is the dimensional formula of force. Okay, okay. So basically, we can have the different physical quantities which have the same dimensions. There can be different physical quantities with the same dimensional formula. Please give me the signal in the chats if everything is crystal and clear. All the people out there with the fire emojis. With the fire emojis. Everyone means everyone. Okay, that's great. That's great. Then we have, my dear friends, Planck's constant. Now, as of now, you just remember, we say energy of a photon is equal to h into f. This we study in the modern physics. If you have studied the modern physics with me in the game of NEET, then I have discussed this formula in the dual nature of matter and radiations. Energy of a photon is equal to h. H means Planck's constant multiplied by frequency. Okay. Now here you can say h is equal to energy divided by frequency. Now, when it comes to the energy, what is the dimensional formula of energy? Recently we got dimensional formula of energy is what? ml2 t minus 2. ml2 t minus 2. Okay. And for frequency, it is t minus 1. So we can say it is ml2 t minus 2 divided by frequency. Frequency is t minus 1. Okay. And this minus 1 will cancel. So it will be ml2 t minus 1. This will be the dimensional formula. Similarly, angular momentum. We say angular momentum is mvr sine of theta. Guys, I told you theta is a dimensionless quantity. So sine of theta is also dimensionless. So I can say in this particular case, L is equal to m. For this mass, it is m. For velocity, it is LT minus 1. For R is length, radius. So that is also length, that is L. So this will become ml2 t minus 1. Spring constant. We say when it comes to the spring constant, we say F is equal to K times of X. You might have studied this. This is the restoring force in the spring. Here you have to find the dimensional formula of K, that is F divided by X. Now what is the dimensional formula of force? That is ml t minus 2. Okay. Okay, mlt minus 2. Mass into acceleration. Yes, mlt minus 2. Now, divided by x. X is length. This and this will cancel. So this will be mt minus 2. This is the dimensional of formula of this. Similarly, you have the dimensional formula of capacitance. Guys, we know capacitance. Capacitance is the ability of the capacitor. Capacitance is the ability or the capacity of the capacitor to store the charge. Now, my dear friends, understand one thing very carefully. We know there is a formula of capacitance Q is equal to CV. Guys. If you are starting from this chapter only, then remember directly. But if you have studied the capacitors with me, which I have completed already in the game of NEET, we have studied the formula capacitance Q is equal to C into V. Q is the charge, V is the potential difference, and C is the capacitance. Now you say here, I'll use this formula to find the dimensional formula of this C. But I say no, don't use this. Use that formula of capacitance. Use the formula of capacitance which involves energy, in which energy is involved. We say use that formula in which energy is involved. Because if you see in your syllabus, in your whole syllabus, we say your syllabus is revolved around the energy only. Simply remember, whenever you have different formulas for a particular physical quantity, try to take that formula which involves energy. It will become simple. Okay? It will become simple. Now, we know that energy stored in a capacitor, previously we have studied energy stored in a capacitor is equal to, I can say 1 by 2, or you can say Q square divided by 2C. Q square divided by 2C. Now, my dear friends, you need to find this. So C is equal to Q square divided by 2U. What is this U? U is the energy stored in the capacitor. Same formula I have taken over here. I want to show you this. So Q square by 2C. Q is the charge, C is the capacitance, U is the energy. Now take the C over here, and 2 is dimensionless. Forget about this 1 by 2. So it is Q square by U. Guys. When it comes to the charge, I want you to understand this. Guys, we say current is equal to charge upon time. Okay. Now, if you want to take it over here, so Q will be equal to I into T. Now, what is the dimensional formula of charge? You can say I into T itself. T raised power 1, I raised power 1, because current is also a physical quantity, fundamental quantity. Some people also write it something like this. This is ampere and this is time, 80. Whatever you want to write, everything is correct. Both are correct. Now, instead of charge, you say I into T, and it is square, so it is square. Divided by energy. What is the dimensional formula of energy? Recently, I told you that is mL2 T minus 2. Done and dusted. Now, guys, tell me in this particular case, this will become m goes in the numerator, m raised power minus 1. L goes in the numerator, L raised power minus 2. I square. And here it is T square. And this T, when it goes in the numerator, so it becomes T raised power 4. This is the dimensional formula of capacitance. Here, I told you to use that formula only, prefer that formula only, which involves the energy, in which energy is there, in which energy is involved. So this is the dimensional formula of capacitance. Similarly, if somebody asks you to find the dimensional formula of inductance, okay. Now, my dear friends, take that formula in which energy is involved. Guys, see. I can say in this particular case, when it comes to the inductance, I have shown you the formula. Flux is equal to L into I. I is current, phi is flux. L will be phi divided by I. But I say don't use this formula. Prefer that formula in which energy is involved. U is equal to 1 by 2 Li square. I is the current. Okay. You have to find the formula of inductance. So L. This is energy. Energy, you know, mL2 T minus 2. Current, you know, done and dusted, put and get the value. Guys, are you able to understand? Please tell me in the chats. Is this clear? Is this clear? Please tell me in the chats. Is this crystalline clear? To each and every single student. Everyone means everyone. Okay. That's great. That's great. Now, guys, similarly, we have one more physical quantity. That's what we call the energy density. Energy density means energy per unit volume, energy upon volume. Guys, for energy, it is ml2 minus 2. For volume, it is L cube. It's simple now, okay? Now do the simplification, you will get it. Similarly, you have got mass density. Whenever you see density, it is mass per unit volume. So we can say mass by volume. Now for mass, it will be m. For volume, it is L cube. So m1 L raised power minus 3. For charge density, it is charge per unit volume. How much charge is present in the unit volume? So I can say over here, this is charge divided by volume. So charge is Q and volume is L cube. Do it and you will get the answer. Similarly, we have areal mass density. Okay. So this is also mass divided by area. When it comes to the areal mass density, it is mass divided by area. So that is ml. For area, it is L square. For mass, it is m. Pressure is force per unit area. Simple, 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 simple. Okay. Now you can find out in your modules, if you are an Unacademy student or wherever you study, you can find a lot of physical quantities in which dimensional formula will be there and you will be able to find out easily. I have shown you the approach. Now guys, let's take a look over here. That is the dimensionless physical quantities. Those quantities which does not have the dimensions, dimensionless physical quantities. See guys, I can say angle, theta. It is a dimensionless physical quantity. Solid angle. What is solid angle? Solid angle is if you take a cone-shaped structure. This is a cone. Over there, there is an angle in 3D. That's the solid angle. We say strain, strain. Okay. This you will be seeing in the upcoming time. Poisson's ratio. Okay. Refractive index. All of these refractive index we have studied previously in we say ray optics. So these are the physical quantities which does not have the dimensions. Okay, these are dimensionless. Trigonometric formulas, like we say sine theta. Sine theta is perpendicular upon hypotenuse. Perpendicular is length, hypotenuse is length. This and this will cancel, so it will become dimensionless. M0, L0, T0. M0, L0, T0. Okay, exponential functions. Okay, it's a pure number. Pure number is also a dimensionless physical quantity. Okay, okay, yes sir, yes sir. Let's move on. Okay, strain. Strain we said over here is a dimensionless physical quantity. Why? We say strain is delta L. What is delta L? Delta L means change in length. Change in length upon original length. Change in length upon length. Guys. If you say change in length, like. If I am saying length is change in length, delta L means final length minus initial length. Let's suppose final length is 5, initial length is 2. So what will be change in length? That is 3. What is this 3? This is also length. So change in length is also length. So I can say in this particular case, change in length is also length, length is also length. This and this will cancel, it will become dimensionless. Coefficient of friction. Guys, we say friction F is equal to mu times of N. This is the formula for frictional force. Here, this is called the coefficient of friction mu. Mu will be equals to frictional force divided by normal force. This is force, this is force. This is mlt minus 2, this is mlt minus 2. This and this will cancel. It will become dimensionless. It will become dimensionless. Pure number 4, 5, 10, 15, all of these are dimensionless. Okay. Okay. So basically all of these are dimensionless. Sir, I bunked the class to listen to your lecture online live. That's great. Good to see you, bro. Welcome to the session. Okay. Now guys, take a look exactly in this particular case. We have got the 4 categories of physical quantities. We have got the 4 categories of physical quantities. Now guys, when it comes to the 4 categories of physical quantities, You say on the basis of dimensions, on the basis of dimensions, these are categorized in four categories. These are categorized in four categories. These are categorized in four categories. Now listen to me listen to me very carefully. Listen to me very carefully. There are, we say on the basis of dimensions, there are categories. We say these are categorized in four different categories. We say first one is dimensionless constant. Dimensionless constant. Guys, see. We say it has dimensions, but their numerical value is constant. Guys, see. When it comes to the gravitational constant, universal gravitational constant, there is a formula. If you have got two masses, m1 and m2, this is m1 and m2. Force exists between these two masses, okay? You say that force is equal, F is equal to G m1 m2 divided by r square. Now, if you want to find what is this G? G is the universal gravitational constant. So you can find this G will be F into r square divided by m1 m2. Now, guys, how can you find the dimensional formula of this? Put the value, dimensional formula of force, mlt minus 2. Dimensional formula of radius, that is length, L square. Mass, m1, m2, that is m into m square. You will get the dimensional formula of G. So basically, and its value is constant. Its value is constant. So we say gravitational constant is that constant which has the dimensional formula, but its value is constant. It is a constant, okay? Like its value is 6.67 in 10 raised to power minus 11. But when it comes to its dimensional formula, here I have calculated its dimensional formula. So that's what I say. It's a dimensional constant. It's a dimensional constant. That constant which has the dimensional formula, but value is constant. We say it has dimensions, but their numerical value is constant. Similarly, gas constant, Planck's constant, etc. There are a lot of constants. Now, my dear friends, second one is over here. Dimensionless constant. That constant which does not have the dimensions at all. Okay? Those quantities which has no dimensions but has a fixed value. They have the fixed value. Example, we say 1, 2, pure numbers like pi. What is the value of pi? 3.14. And when it comes to the dimensional formula of pi, that is, it's dimensionless. Okay. Then we say dimensional variable. What is dimensional variable? We say it has dimensions but does not have a fixed value. Okay. It has dimensions but does not have a fixed force. Guys, force can be 10 Newton also, 20 Newton also, 50 Newton also, 0 also. So the value of force can be anything. It's a variable. It's variable. But it has got a dimensional formula. That variable which has dimensional formula, okay, and its value is variable. Its value is not fixed. Velocity, acceleration, okay. Next, dimensionless variables. Those variables which has got no dimensions, it has no dimensions, does not have a fixed value. It does not have the fixed value. Also, it does not have the dimensions. Refractive index. We say for different mediums, refractive index is different. Like for air, we take refractive index 1. For any other material, we take refractive index something else, 50, 30, 40. So refractive index, we say for different, it is different. Okay. And it is a dimensionless. When it comes to the refractive index mu, it's a dimensionless physical quantity. Plane angle. Okay. Example, etc. Relative permittivity. Yes. Relative permittivity, that is mu r. Sorry, ER. Okay. Relative permeability. So relative permittivity for different mediums is different. For air, it is something. For water, it is something. For glass, it is something. So relative permittivity for different mediums is different. And when it comes to the dimensions of relative permittivity, it's a dimensionless physical quantity. Okay. Is that clear? Is that clear? Guys, tell me. Tell me. Okay. That's great. That's great. That's great. Okay. Now, guys, principle of homogeneity. Principle of homogeneity. Let's take a look exactly over here. Principle of homogeneity. What does principle of homogeneity actually say? What does principle of homogeneity actually say? According to the principle of homogeneity, we cannot compare two different physical quantities. We cannot compare two different physical quantities. Like if I'm saying, let's suppose, my dear friends, I say I have got a rod over here. This is a rod. Okay. Okay. When it comes to the mass of the rod, it is 10 kgs. Okay. When it comes to the length of the rod, it is 15 meters. Length of the rod is 15 meters. What I'm saying in this particular case is, I'm saying, sir, length of the rod is greater than mass of the rod. Mass of the rod. Tell me, is it correct or incorrect? Tell me, is it correct or incorrect? Sir, I am an Akash student, sir. I missed the physics class for your lecture. That's nice. Good to see you. Welcome to the session. Okay. Now, guys, take a look. In this particular case, length of the rod is greater than the mass of the rod. In this particular case, I would say it is wrong. Why? Because it is incorrect. You cannot compare mass with the length. Length is a different physical quantity. Mass is a different physical quantity. Yes, if it was over here, if I say this is a rod, length of this rod is, we say, sir, 5 meters. Okay. You can say length of the first rod is greater than the length of the second rod. Why? Because length and length are the same physical quantities, similar physical quantities. But when it comes to the mass and length, these are the different physical quantities. You cannot compare. It is incorrect. It is incorrect. It is incorrect. Okay. It is incorrect. So, my dear friends, that's what does the principle of homogeneity say. We cannot compare two different physical quantities like 4 meters plus 2 kgs. Can you add 4 meter length with the 2 kg mass? It is absolutely wrong. So, not possible. It is incorrect, wrong. We say 3 meters minus 2 seconds. Meter is length, second is time. Okay. Meter is length, second is time. 3 meters minus 2 seconds is equal. It is not possible. It is wrong. Okay. Now, my dear friends, Vani Burhan, I have finished the syllabus over there. Okay. That's why. Now, my dear friends, it is not possible. It is incorrect. Then we say 5 kg is greater than 3 meters. 5 kg is greater than 3 meters. Is it correct or incorrect? Sir, it is incorrect. You cannot measure the mass with the length. So it is not possible. It's wrong. But if we say 8 meters plus 7 meters is 15 meters. 8 plus 7 is 15. This is length and this is length. Similar physical quantities you can add, you can subtract, you can compare. There is no problem in that. Okay. But my dear friends, one more thing I just want to mention. One more thing I just want to mention in over here. This principle of homogeneity also says that two quantities must be of same unit. Dimensions like length, same unit, same dimensions, which can be added or subtracted or equated. The two physical quantities which you want to compare, add, subtract or equate, they must have the same units and dimensions. This is called the principle of homogeneity. Okay, but there is one more thing. You can multiply two different physical quantities like guys, we say force is equal to mass into acceleration. When you multiply mass with the mass is a one physical quantity, acceleration is another physical quantity. You can do this. You can do this. It is possible. It is possible. So multiplying two different physical quantities is okay. There is no problem in that. Momentum is mass into velocity. But adding, subtracting or dividing is not possible. sorry, adding, subtracting, equating, comparing is not possible, but multiplying, dividing, all of these is possible. Multiplying and dividing is possible. Is this crystalline clear to each and every single student? Is this crystalline clear? Guys, tell me in the chats. I would want you guys to let me know with the fire emojis and smash the like button. Tell me, guys. Tell me. Great, great. Now, guys, this is an important question which I would like to ask you over here. Is which, okay, if A and B are different physical quantities, then which one is correct? A, B, C. If A and B are different physical quantities, then you guys are supposed to tell me which of the three options or which of the three options is correct over here. Tell me. Tell me, guys, in this particular case. Guys, if A and B is a different physical quantity, we already saw that according to the principle of homogeneity, two different physical quantities cannot be added, subtracted, equated, compared. So we say A is wrong, incorrect. Already we saw the reason. Sir, this is correct. Why? We can say acceleration is force divided by mass. Two different physical quantities can be multiplied or divided. We say force is one physical quantity, mass is another physical quantity. What about option C? I would say when it comes to the option C, it is correct. Let me show you why. Let me show you why. See, guys, you have to solve it. We say if let's suppose we assume A is equal to area. Let's consider this physical quantity as area. Let's consider this B is equal to length. Okay, B is equal to length. Now tell me, guys, can I say, so this would be area minus, this is over here, length square. Tell me, guys, one thing. This is area minus length square, length into length. I guess that is also area. Length into breadth is area. Breadth is also length. Length into length is area. So I can say this is area minus, I can say this is area. Now it becomes the similar physical quantities. You can subtract area and area. So yes, it is correct. So it is possible. You have to basically see according to the equation whether it satisfies the condition or not. Is this clear? Is this clear? I hope this is crystalline clear to each and every single student. Now, guys, this is also important. I would want you guys to solve this particular question also in this particular case. If velocity v is equal to alpha t plus beta x minus gamma xt, then find the dimensions of alpha, beta, and gamma. You guys are supposed to find out the alpha, beta, dimensions of alpha, beta, and gamma. Guys, see. The very first thing that I must tell you over here is, see. I can say, sure, this velocity is equal to this plus this plus this. We say, guys, two different physical quantities can be only added, subtracted, or equated if they are similar, So my dear friends, I can say, according to principle of homogeneity, POH, okay, according to principle of homogeneity, two different physical quantities can be only added I would say subtracted or equated if they are similar. If they are dimensionally, if they have the same unit dimensions, okay, now my dear friends, so we can say, so guys, according to this logic, can I not say, I would want you to focus, can I not say this V will be equal to alpha t? So we can say this V is equal to alpha t, okay, will be equal to beta into x, will be equals to gamma x t, gamma xt. So we say these physical quantities can be only equated, added, subtracted if they are similar, if their dimensions and units are similar. Yes. Now, so can I not say in this particular case, I would want you guys to focus, can I not say, so I can say V is equal to alpha t. Yes. Now tell me, what is alpha? Alpha is equal to V divided by t. What is V? V is the velocity. Guys, what are the dimensions of velocity? Lt minus 1 divided by, this is t. Now take this in the numerator, so it will become Lt minus 2. So this is these are the dimensions of what? Alpha. This is the dimensional formula of alpha. Now similarly, if you want to find the beta, you can say V is equal to beta x. So for beta, you would say that is V divided by x. Now tell me, for V it is Lt minus 1. For x it is L. This and this will cancel, so it will become T raised power minus 1. So for beta, dimensional formula is T raised power minus 1. Now guys, in this particular case, can I not say similarly, when it comes to this, we can say also V is equal to gamma xt. Tell me, can I say over here, this gamma will be V divided by xt. So can I say this is Lt minus 1 divided by, this is L, x is length, t is time. This and this will cancel. So for gamma, it is T raised power minus 2. How many of you understood this? Please tell me in the chats. How many of you understood this? Please tell me in the chats. Everyone means everyone. Let me know if it is crystal clear to each and every single student. Now guys, tell me the answer of this particular question. Tell me the answer of this particular question. Okay. Now guys, in this particular case, if force is equal to F is equal to A root X plus, I'll just show you the approach in this particular case, you will be answering this particular question. Then find the dimensions of A and B. You have to find the dimensions of A and B. Guys, see. Here, I can say, according to POH, two different physical quantities can be added or subtracted only if they are similar. So I can say this force is equal to root A into X plus this is beta into, we can say, T over here. Now guys, tell me one thing in this particular case. So can I say, we say this will be equal to this and will be equal to, I can say this B into T will be equal to B into T. Now first do this one, equate these two. So F divided by A divided by F divided by X is equal to, I can say, root A. F divided by X is equal to root A. Take this root over here, it will become square. Okay. So I can say A will be equal to F square divided by over here X square in this particular case. Okay. Because if you take this over here, it will become square. Now my dear friends, in this particular case, could you please tell me, this is A is equal to, so what is the dimensional formula of this? M L T minus 2 whole square upon, this is X and it will be square. For X it is L square. Okay. Now tell me in this particular case, this will be A is equal to, guys, this is M L square T minus 2 divided by L square. This and this will cancel. M T raised power minus 2. Similarly, can I not say also in this particular case, I can say this F is equal to B into T. F is equal to B into T. So B will be equals to F divided by T. And what is the dimensional formula? What is the dimensional formula in this particular case? Okay, oh, this is square. Just a second. This is square for this also. 2 into is minus 4. So it will become M square T raised power minus 4. Please correct it, guys. So A is equal to, this is square, that is M square L square T raised power minus 4 upon L square. This and this will cancel. Okay. So this A will come out to be M2 T raised power minus 4. Okay. Tell me about this one. Tell me about this one. So this is MLT minus 2 and this is T. So this will become MLT minus. Guys, give me the signal in the chats if this is crystal and clear to each and every single student. Everyone. Okay. Tell me the answer of this question. This is also important. Tell me the answer of this question. Everyone. See guys. When it comes to this particular question, simply, if y is equal to sine of alpha t, then find the dimensions of alpha. Whenever you see the questions of this type, what you guys are supposed to do is that we say, put alpha t is equal to theta. Put this alpha t is equal to theta, because it is like y is equal to sine theta. So I can say when it comes to the theta is equal to alpha t in this particular case, because it looks like y is equal to sine theta. So you can consider this angle as theta as a whole. Now guys, theta is a dimensionless, so it is 1 upon, and this will be t in the denominator will be equal to alpha. So alpha is equal to t raised power minus 1. As simple as that. As simple as that. Next. If you have the question of this sort, if v is equal to a sine of x under root of alpha t, then find the dimensions of alpha. What did I tell you? Assume in this particular case, assume theta is equal to, I can say x under root of alpha t. This x under root of alpha t, you assume it equal to theta. Okay. Then, guys, tell me, can I say this is dimensionless 1 upon this? We have to find the dimensions of alpha. This is 1 by x and is equal to, I can say, under root of alpha, and this is t over here. Now tell me guys in this particular case, if we take this root over here, it will become square. So 1 upon this is x square in this particular case will be equals to alpha t, Now guys, can I say in this particular case, this alpha will be equal to 1 upon, this is t, take this t in the denominator, so it will be x square. Now, so I would say 1 upon, what is the dimensional formula? This is t raised power 1, this is L raised power 2. Take this in the numerator, so it will become, so L raised power minus 2, t raised power minus 1. L raised power minus 2, t raised power minus 1. Okay, this is whenever you see the question of this sort, just put this is equal to theta. That's it. Okay. Okay, one more. Find the dimensions of d2y by dx square, where y is force and x is displacement. This I'll give you as homework. Okay. And I would want you guys to answer in the comments later on. Answer in the comments. Okay. I would be waiting for your answer in the comments. Next, check the equation is dimensionally correct or incorrect. Check the equation is dimensionally as well as dimensionally and physically. Check if the equation is dimensionally as well as physically correct or incorrect. You have to check whether this equation, and this equation is dimensionally as well as physically correct or incorrect. Guys, see. When it comes to the formula of kinetic energy, we say it's 1 by 2 mv square. Yes, sir, it is correct. So I can say this is physically correct. So this formula is physically correct. Now, guys, tell me one thing. When it comes to the dimensionally, I can say, what is the dimensional formula of this one? Sir, for kinetic energy, it will be. Tell me. What is the dimensional formula of kinetic energy? For m, it is m. Okay. For velocity, can I say it is LT minus 1 and it is square. So it is ML2 T minus 2. Yes. So it is dimensionally correct. I can say it is dimensionally correct. Yes. Now, guys, tell me one thing. What about this formula? Is it physically correct? No, sir. This is not the formula of kinetic energy. That is 1 by 2 mv square. It is 2 by 5 mv square. So I can say this is physically incorrect. Okay. And when it comes to the dimensionally, guys, for this, it's a dimensionless quantity. 2 by 5, it's a pure number. For this m, and this will be L2 T minus 2. So yes, it is dimensionally correct. Dimensionally correct. Now tell me, guys, in this one, this is physically incorrect. Okay. And when it comes to the dimensionally, it is correct because sine theta is dimensionless. We say trigonometric ratios are dimensionless. So this is dimensionally correct. Dimensionally correct. Because here you have got mv square. So dimensionally correct, all the three, physically incorrect. Now, there is a statement. From this, we can say, if an equation is dimensionally wrong, okay, if an equation is dimensionally wrong, then physically also it will be wrong. Okay. Now, see, all the three, if we check this one, this is dimensionally correct, we say it is physically correct. Okay. If an equation is dimensionally wrong, let's suppose I'll make another formula over here. Okay. We say physically also it will be wrong. Okay. If you change the formula, like if we say over here, kinetic energy is equal to 1 by 2 m square v square. So its dimensional formula will be what? That is m square L square T raised power minus 2. Okay, T raised power minus 2, which is not the dimensional formula of kinetic energy. So if it is dimensionally wrong, you see, physically also it is wrong. Okay. Okay. So if an equation is dimensionally wrong, physically also it is wrong. Next point. But if an equation is physically wrong, dimensionally, physically wrong, it can be dimensionally correct. If an equation is physically wrong, dimensionally it can be correct. See, this equation is physically wrong. Dimensionally it can be correct. Is this clear? Please tell me in the chats. Everyone, with the fire emojis. Tell me. Smash the like button if you have not liked the session, and I would want all of you to hit it. Hit the like button. Now, guys, take a look. Take a look exactly over here. Significant figures. Now, guys, what are these significant figures? That's what we need to discuss over here. Rules for significant figures. Simple. We say all non-zero digits are significant. Let's suppose I am giving you over here a number 5, 6, 8, 7, 8. Sir, and ask you the question, how many significant digits or how many significant figures are in this particular number? You say 1, 2, 3, 4, 5. There are 5 significant figures. Why? Because the first rule of significant to finding out the significant figures is all non-zero digits are significant. So how many significant digits are in a particular number? So we say all non-zero will be significant. 5, 6, okay, has 2 significant figures. 30, 3, 8, 7, 5 will be 4 significant figures. Okay, all zeros between non-zero digits are significant. Like you say 6, 8, 0, 0, 7, 5. Sir, in this case, how many significant digits? We say 1, 2, 3, 4, 5, 6. Because these are the two non-zero, sorry, these are the zeros, all zeros between non-zero. These are between the non-zeros. So we consider them as significant. All zeros on the left side are non-significant. If you have the zeros on the left side, 0, 0.415, okay, so then we consider those as non-significant, okay, 0.545. In this case, we say 3. Next, power forms are not considered to be the significant. Like you say 4, 5, 8 into 10 raised power 17. This is non-significant. Non-significant. So here we consider only these 3 as significant. Power forms are not considered to be significant. Trailing 0 after the decimal is significant. Okay. We say, my dear friends, we say, if you have the zeros after the decimal, we consider those as significant. Like we say 25.00. So significant. 1, 2, 3, 4. Total of 4 significant digits. Okay. Like if you do the conversion, 85 mm, 8.5 centimeter. Okay. Like here, how many significant digits? 2. How many significant digits? 2. 0.085. How many significant digits? 2. Because the zeros which are on the left side, we do not consider them significant. Okay. 8.5 into 10 raised power minus 2 meters. You can write it something like this. So here, how many digits? 2. 2 significant, because power form we do not consider as significant. So if you are doing the conversion of numbers, the significant number remains the same. Like you can say 0.000085 kilometers. So 85 mm is this much of kilometers. Here also, we do not consider them as significant. Only these two will be significant. Now, tell me, is this crystalline clear to each and every single student? Is this is a simple topic, yeah? Is this crystalline clear to each and every single student? Tell me. Simple. There are some rules that you have to follow. Just a second. Tren tam asa ready है? तो लोगों ना win साथ. चलो ठीक ठीक ठीक. Okay okay चलो अस्सलाम वालेकुम. Okay guys, tell me, is it clear? Great, great, great. Now, guys, fine. See. Now, this one is important that I'll mention over here. Addition and subtraction of significant figures. Addition and subtraction of significant figures. We say final result is written in the minimum decimal place. Minimum decimal place. What I'm trying to say in this particular case is, guys. If you have a number over here, that is 25.413 plus 1.2, and I am asking you, guys, how kind again 2 by 3 mv square is physically correct? It is physically incorrect. Who told you it is physically correct? Did I mention it physically correct? I said it's physically incorrect. Okay. Let's suppose if you have a question over here that is mentioned on the screen, that is present on the screen, and you guys are supposed to tell me, in this particular case, find the value of a plus b. When it comes to the a plus b, what will you say? What will you say over here? 2.413 plus 1.2. Okay. So it will be simply a plus b will be 2.413 plus 1.2. 2 plus 1 is 3. So it will be simply 3 point. Okay. In this particular case, 4 plus 2 is 6, 1. Okay. 3 over here. 613. Now, guys, in this particular case, when you have to do the addition and subtraction, remember this rule. Final result is written in minimum decimal place. Tell me one thing over here. How many digits are here after the decimal? Sir, this is only 2. How many digits are over here after the decimal? 1, 2, 3. Okay, here it is 1 only. Here, how many are there? 3. So you have to write the final result in minimum decimal place. So you have to make this answer in such a way so that after the decimal, there should be only one number. So the answer, the correct answer or the final answer in this particular case will be 3.6. We cannot say 3.613. Why? Because in case of addition or subtraction of significant figures, final result you are always mentioned in the minimum decimal place, that is 3.6. Because here after the decimal it is 2 only. There are only, we say, only one digit only. That's why. Okay. Now, there was a question exactly asked in the NEET 2020 on this particular thing. You guys are supposed to tell me which of the 4 options is correct without solving the question. Which of the 4 options is correct over here? Tell me. Which of the 4 options is correct over here? In the chats, everyone, guys, let me know in the chats. Tell me. See, when it comes to the addition and subtraction of significant figures, taking into account of significant figures, what is the value of this minus this? Guys, whatever the answer is, it should be in the minimum decimal place. Guys, see. In this case, how many digits are after the decimal? There are 2. 9, here 9 and 9. This is 2. Here how many? 1, 2, 3, 4. There are 4. So in this particular case, which option is correct? Sir, option A. Because here after the decimal, you have got 2. So whatever the final result is, we say in that particular case, the final result is written in the minimum decimal place. So this. Okay. So you mention over here, final result is written in the minimum decimal. Now, let's move on to which one? Multiplication and division. Let's suppose, my dear friends, you have got A, you have got B. Here, in case of multiplication and division of the significant figures, we say final result is written in the minimum significant figures. Guys. How many significant figures are over here? We say 3. How many significant figures are over here? We say 1. So final result should be in such a way so that it should have 1 significant figure. Why? Because in case of multiplication and division, final result is written in minimum decimal place. Sorry, minimum significant figures. Now tell me guys, in this particular case, if I say A divided by B over here, what will you say? That is 25.5 divided by 5. 5 ones are 5 fives are. 5 ones are 0.1. So I can say answer is 5.1. Now guys, what should be the answer? Answer should be 5. Because in case of multiplication and division, final result is written in the minimum significant figures. And here minimum significant figure is 1. I hope this is crystal and clear to each and every single student. Yes. Now comes the rounding off. Now comes the rounding off. Okay. Take a look, guys. Take a look, guys. When it comes to the rounding off, see. Listen to me very carefully. Listen to me very carefully. We say if the digit to be removed is greater than 5, okay, then the previous number increases by 1. Then the previous number increases by 1. See, guys. Let's suppose you have 3.67. You want to round off this. Okay. Okay. Now, in this particular case, what you are supposed to do is, you have to see if the previous number is greater than 5. If the previous number is greater than 5. If the digit to be removed is greater than 5. If you want to remove this digit, if it is greater than 5, 7 is greater than 5, then previous number increases by 1. What is before 7? That is 6. 6 will increase by 1. So it will become 3.7. If the digit which you want to remove is greater than 5, then previous number increases by 1. So it will become 6 plus 1 is 7. So 3.7 meters. Okay, this is what we call the rounding off. If somebody asks you, round off this to 2 digits. How many digits are over here? 1, 2, 3. If you have to round off this to 2 digits, you will be writing 3.7, not 3.6. Why? Because the digit you want to remove is greater than 5. So previous number has to increase by 1. Okay, so it is this one. Okay, okay. Let's suppose if it is 3 point or it is 4.79. Round off to 2 digits. You say here last digit is greater than 5. So previous digits increase by 1. So it will be 4.8. So it will be 4.8. Next. If the digit to be removed is less than 5. If the digit you want to remove is less than 5, like 3.62. This is less than 5. Okay. Okay. Then there is no change in the previous number. Then there is no change in the previous one. See guys, 2 is less than 5. So the previous one will not be changed. So it will remain 3.6. It will remain 3.6. If I say 4.73, it will be equal to 4.7. Why? Because this is less than 5. Okay. Next, because last digit is less than 5. Next, if the digit is 5, okay, if the digit is 5, then the previous number remains the same if even and increases by 1 if odd. Now guys, if you want to remove this last digit, which is 5 itself, if it was greater than 5, we would have added 1 to this. But if it was less than 5, then we would have kept it same. But in this case, it is exactly 5. What we are supposed to do, we say round off up to 3 digits. We have to make it up to 3 digits. Guys, see, it says that if the digit to be removed is 5, then the previous number remains the same. Previous number remains the same. If it is even, and increases by 1 if it is odd. Tell me. Here, this 7, tell me one thing. Is 7 odd or even? 7 is odd. 7 is odd. Okay. If 7 is odd, then we say previous number, then we say it increases by 1. It increases by 1. So we can say 3.675 will be 3.68. 7 will increase by 1. So it'll be 3.68. Another example, if I say over here, I can say 4.7, 4.73, 4.735. Last digit is 5. Okay, and before the last digit, it is odd. So it will increase by 1. So it will be 4.74. 4.74. Next. Okay. And see, 3.685. Guys, last digit is what? 5. And digit before the last digit is even. This is even. So in that case, it will remain the same, because it says if this digit before the last digit is even, that it remains the same. So it will remain this only, 3.68, and it remains 3.68. These are the only 3 rules that you see in the rounding off. These are the only 3 rules that you see in the rounding off. Okay. Okay. Follow these 3. Tell me. Tell me. This one. Homework. 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 Next one. Measuring instruments. Measuring instruments. Measuring instruments. Okay. Now, guys, it'll take us 2 more hours and we are done with the chapter. Okay. It'll take us 2 more hours and we are done with the chapter. Let's finish this measuring instruments. Okay, how many slides are there? Take a look, guys, over here. See, let's take a look. Measuring instruments, the first measuring instrument we use is meter scale. So we say it's an instrument which helps us to measure the length. These are the measuring instruments that we need to study. Meter scale, we have screw gauge, we have vernier caliper. So these are the 3 measuring instruments that we have to see. Guys, all of you might have seen this in your real life. This is what we call the meter scale. Okay. Like this is 1 centimeter, 2 centimeter, 3 centimeter. Okay. And so on and so on. Now guys, tell me one thing in this particular case. See. I'll give you the crystal clear feel of this. We say from here to here, we say this is 1 centimeters. This is how much? What is the length of this one? This. If you see from here to here, this is actually how much? This is 1 centimeter. This is 1 centimeter. Okay. And if you check over here, exactly, if you check over here, now this is in 1 centimeters, how many mm's are there? This is 1 mm, 2 mm, 3 mm, 4 mm, 5 mm, 6, 7, 8, 9, 10. So in 1 centimeters, how many mm's are there? We say 10 mm's are there. So in this 1 centimeter, we say there are 10 mm's. In 1 centimeter of the meter scale, there are 10 mm's. There are 10. This is 1 mm, 2 mm, 3 mm, and so on. And this 1 mm, 2 mm, 3 mm, this is what we call the main scale divisions. We also call it the MSD. So how many main scale divisions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So can I not say from this 10 main scale divisions? Main scale divisions is equal to, we say 10 mm. Yes. Okay. Which is further equal to 1 centimeter. So 10 main scale divisions is equal to 10 mm, which is further equal to 1 centimeter. Okay. And if somebody asks you what is the value of one main scale division, one main scale division, okay, what will you say? Sir, that will be 1 divided by 10 centimeter. Guys. If you are saying over here 10 main scale divisions is equal to 10 mm, or you can say 10 MSD is equal to 1 centimeter. Yes. What is the value of 1 MSD? You will say 1 MSD will be 1 divided by 10 centimeters. And this is equal to 1 mm, because 1 MSD, 1 mm, it's one and the same thing. It's one and the same thing. Okay. Yes, sir. This one. Now guys, listen to me very carefully. Listen to me very carefully. Let's see this meter scale in a zoomed view. What is the meaning of that, guys? I'm not making the entire whole scale. I'm just making this part of the scale in the next slide. This part of the scale, like 1 mm, 2 mm, 3 mm, 4 up to 10 mm. Just take a look. Sir, it is a whole scale. I'm taking this part only, 1 mm, 2, 3, 4, 5, 6 and 10 mm. So these 10 mm I'm making over here in a zoomed view. As from now on, a lot of students come to me, they say, sir, I have a confusion in this measuring devices, measuring instruments, but I'm giving you the 100% assurity. If you give me the 100% attention over here, you won't be having any sort of doubt afterwards. That's the guarantee. Okay. Now, I'm making the zoomed view in this particular case. Yes, sir, I'm making the zoomed view in this particular case. So this is 10 mm. Guys, see. Let's suppose I have got a rod. I have to measure the length of the rod over here. Understand very carefully. Sir, this is the length of the rod. This much is the length of the rod. Could you please tell me how much is the length of the rod? Will you say, sir, 3 mm is the length of the rod? Will you say 4 mm? Sir, it is greater than 3. It is less than 4. What is the actual length of the rod over here? Understand this very carefully. Guys. If I say, sir, this much is the rod. You say, sir, it is 1 centimeter plus 0.5 centimeter. So it will be 1.5 centimeter till over here. But if you say, sir, till here, 1.5 centimeter you can measure. But between this and this, there is no reading present over here. There is nothing mentioned. So you won't be able to measure this much. With the help of the meter scale, you can measure this much of the length. You can measure this much of the length, which is exactly till over here, till these lines. But if it comes in between the lines, you won't be able to measure it. Okay. So here, similarly here, between 3 mm to 4 mm, if the rod is ending, you won't be able to measure its exact length. Okay. So my dear friends, I can say this rod can measure up to here, up to here. But if it comes in between, it won't be, because there is no reading present. See, how do we mention the reading in this particular case? We say the length of the rod length reading is equal, sir, 3 mm, we are sure. It is 3 mm, we are sure. Yes, 3 mm is correct. Then we say plus minus 1 mm. Sir, so then it is from this to this. It is how much? 1 mm. This we are not sure. How much it is? 0.5, 0.6. Some will say, sir, it is 0.5, 3.5. How do you know it is 0.5? Is it mentioned over here? No, you cannot say. So that's why we say plus minus this. So we say this is the error. Maximum error. Maximum error in this particular case will be 1 mm. Maximum error can be 1 mm. Sir, this maximum can be 1. But if it reaches over here, then we'll get sure, sir, it is 4 mm. So maximum error will be 1 mm. So how do we measure the reading? 3 mm plus minus maximum error. Okay. Now guys, so reading or the length of this is, we say length is main scale reading. Main scale reading is this 1, 2, 3, 4, 5 plus minus least count. Least count is the maximum error or the minimum length this instrument can measure. Guys, tell me, what is the minimum length it can measure? Sir, it can measure minimum length of 1 mm. If it is less than 1 mm, it won't be able to measure. That's why we say this is least count. That's why we say this is LC is what we call the least count. Either you call it the least count or you call it the maximum error. It's one and the same thing. It's one and the same thing. It's one and the same thing. Tell me guys here. If you have L1, what is the length of L1? The length of L1 is main scale reading plus minus least count. Least count is 1 mm for meter scale, fixed. Now, what is the main scale reading? That is 4. It has crossed 4. This is the main scale reading, 4. So it is 4 mm plus minus 1 mm. What is the length of the second one? Second one in this particular case is 4 plus minus 1 mm. What is the length of the third? Third is exactly, we say, sir, 5 mm. Plus minus, you can say 0. So 5 mm. 5 mm. Tell me, is this clear? Is this clear? So how do we find the reading or the length using the meter scale? Meter scale. So you can say in this particular case, that is main scale reading plus minus, we say least count or maximum error. Okay. So we say the minimum measurement, a meter scale can take is 1 mm, is 1 mm. Less than 1 mm, it won't be able to measure. Guys, give me the signal in the chats. Is this clear? Give me the signal in the chats. Is it clear? Everyone means everyone. I would want you guys to give me the signal in the chats if it is clear. To each and every single student. Great, great, great. Now, take a look exactly over here. Take a look exactly over here. Least count. Can I say least count is the minimum reading that can be taken by the instrument? The minimum reading that can be taken by the instrument. Like, what is the least count for the meter scale? That is 1 mm. Because this is the minimum reading that we can take with the help of the... If it is less than 1 mm, we won't be able to measure with the help of the main scale, meter scale. Okay. Or we say the maximum possible error that can be produced by the instrument. Maximum error it can produce 1 mm, not greater than 1 mm. Okay. Okay. So I will mention one more point over here. If the length is less than 1 mm, if the length is less than 1 mm, then meter scale cannot measure that length. Then meter scale cannot measure that length. Keep that thing in your mind. Keep that thing in your mind. Meter scale cannot measure that length. Okay. Now comes the next instrument. That's what we call the vernier caliper. Okay. Vernier caliper. And vernier caliper looks something like this. This is how does a vernier caliper actually look. Okay. So basically it has got two scales. This one is what we call the vernier scale. This one is what we call the main scale. So this vernier scale is slidable over here. It can slide on the main scale. It can slide on the main scale. Okay. And if you want to, measure the length of the rod, then you place it over here, then you increase or decrease this one. Let me show you how does this vernier caliper actually works. How does it work? So when it comes to the vernier caliper, it has got two scales. This one is the meter scale. This one is the vernier scale. It has got two scales, vernier scale and meter scale. This vernier scale is slidable. We can slide it onto the vernier caliper. I have shown you. Okay. Now, when it comes to the meter scale, guys, we have made the meter scale over here. This is 1 mm, 2 mm, 3 mm, 4, 5, 6, 7, 8, 9, 10. So these are the 10 divisions, main scale divisions. 10 main scale divisions, or 10 mm or 1 centimeter. Then you have got the vernier scale. In case of vernier scale, you make, sir, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, guys, here, these are the 10 divisions of the vernier scale. So these are what we call 10 VSD, vernier scale divisions. These are called 10 MSD, 10 main scale divisions. 10 main scale divisions, 10 vernier scale divisions. Don't you think that, sir, 10 vernier scale divisions is equal to 9 main scale divisions? Clearly, you can see over here. 10 vernier scale divisions is equal to 9 main scale divisions. This is how we do it. So, 10 VSD is equal to 9 MSD is equal to 9 mm. Why? Because we say 1 mm is equal to 1 VSD. In this particular case, we say 10 vernier scale divisions is equal to 9 main scale divisions. Okay. Similarly, if you have to find out one vernier scale division, what will you say? 9 mm. Okay, 9 mm divided by this 10. If you are saying 10 VSD is equal to 9 mm, what will you say? 1 VSD. 1 VSD will be equal to 9 by 10 mm. 9 by 10 mm will be what? 0.9 mm. 0.9 mm. So in this particular case, what is the length of this? This is 0.9 mm. So this 1 VSD is equal to 0.9 mm. 1 VSD, length of this. And how much is this? Is 1 mm. Now tell me one thing, guys. If I say till here it is 1 mm, till here it is 0.9 mm, how much will be this? This will be 0.1 mm. This will be 0.1 mm. Okay, because 0.1 plus 0.9, it will be total of 1 mm from here to here. I hope this is clear. Okay, now guys, see. If this is 0.9, this is 0.9. 0.9 plus 0.9, this division, 0.18. So can I not say from here to here it is 2 mm? Okay, from here to here it is 0.18 mm. How much will be this? 2 minus 0.18. So this will be 0.2. Absolutely clear. No doubt in that, sir. 0.2. Okay. Similarly, this is 0.9, 0.9. So this will be 0.27. Until here it is 3 mm. So 3 mm minus 0.27. So can I say in this particular case that will be 2.7. So in this particular case, can I say this will be over here, that is 0.3. This is from here to here it is 2.7. Okay. So I can say this in this particular case will be 0.3. 2.7 and 0.3, this will be 3. So first one is 0.1. This is 0.2, 0.3, 0.4, and so on. It keeps on going. Is this clear till over here? Tell me, guys. Is this clear? I need to know if this is crystalline clear. Give me the signal in the chats. Great. Now, guys, take a look. See, how do we how do we measure the length of the rod using this meter scale? Sorry, vernier scale, vernier caliper. See, guys, since this is slidable, guys, what I'm trying to say in this particular case is that, let's suppose you have got, this is the rod which you want to measure. This is the rod which you want to measure. What you will do is that, you will slide this vernier scale over here. You'll slide this vernier scale over here. When you slide this vernier scale over here, guys, see. When you slide this, when this one is coinciding with this one, guys, tell me, if this one is coinciding with this one, means how much the vernier scale has slided. You would say, sir, it has slided 0.1, because then only this will coincide with this. My dear friends, if I am saying you slide this, if this comes till here and if they are coinciding, means how much you have slided? 0.1 mm. So in that particular case, what will be the length of the rod? Length of the rod will be 0.1 mm. Length of the rod will be 0.1 mm if you slide it. Okay. Now, my dear friends, if let's suppose I have a bigger rod in this particular case, if you slide this once more, now let's suppose this 2 coincided with this 2, okay? In that particular case, how much you have slided? 0.2. So the length of the rod will be 0.2. Please give me the signal in the chats if this is clear, because this is one of the difficult topics that students feel we are not able to understand how the vernier caliper actually works. So we say when you slide this, if this coincides with this one, 0.1 mm. If this coincides with this, 0.2 mm in that particular case. Now, guys, directly, we don't have to go in much depth. You understood the concept, how this works. Now, let me show you how do we take the reading. Length of the rod is main scale reading plus least count, okay, multiplied by vernier scale reading. I'll show you. Least count of this will be how much? When it comes to the least count will be minimum reading that we can take, using this vernier caliper. How much is the minimum reading, sir? 0.1. If it is less than 0.1, I don't think it is possible for me to measure. Okay. So 0.1 mm is the least count of what? Vernier scale. I can say main scale reading plus vernier plus least count multiplied by vernier scale reading. Now guys. How do we find the least count? See. Least count of this will be 1 MSD, 1 main scale division minus 1 VSD. This is the least count of vernier scale. This is the way to find least count of vernier caliper. Okay, so 1 MSD minus 1 VSD. Tell me one thing. What is the value of 1 MSD, 1 main scale division? Sir, we know 1 MSD is equal to 1 mm. What is the value of 1 VSD? 0.9 mm. Now, in this particular case, guys, we say 1 MSD is 1 mm. 1 VSD is 0.9 mm. So 1 minus 0.9 is 0.1. So this is the least count of what? Vernier scale. This is the least count of what? Vernier scale. Done. Next. Let's take the reading. Let's suppose we have got a rod over here. Let's suppose we have got, this is the rod that I'm placing over here. This is the rod. Okay. I am supposed to measure the length of this rod. See. Guys, when it comes to the reading, what will you say? You say main scale reading, MSR. Then you say plus least count multiplied by VSR, vernier scale reading. Guys, see. How do we take the main scale reading? Understand this very carefully. Guys. This rod, if you take a look at the main scale, this is main scale. How much it has crossed? It has crossed 1. It is greater than 1. So main scale reading in this particular case will be 1 mm. It has crossed 1 mm. Okay. Then we say plus, plus. Least count. Least count of vernier scale is how much? We say 0.1. 0.1. Then vernier scale reading in this particular case will be how much? Sir, vernier scale reading, see, I'll tell you how to take the vernier scale reading. Which of the lines is coinciding with, which of the lines of the coinciding of the vernier scale is coinciding with the meter scale? I think over here, these are coinciding. These are coinciding. So we have to take over here, this is 2. This is 2. Now tell me, how much will be this? How much will be this in this particular case? I can say it will be 0.2 in this will be 1.2 mm. Guys, main scale reading in this particular case will be sure how much it has crossed in the main scale. Okay, least count is 0.1. Then you have to check on the vernier scale which number is coinciding with the meter scale. 2 is coinciding with 3. So that's why I took the vernier scale reading as 2. Guys, tell me, is this crystal and clear? Is this crystal and clear to each and every single student? Is this clear? Is this clear? Okay. So this will be how much? 0.2 plus 1. So it will be 1.2 mm. Okay. Is this clear? Okay. So mention over here, VSR is equal to 2 because 2 of vernier scale is coinciding with 2 of vernier scale is coinciding with 3 of main scale. 2 of vernier scale is coinciding with 3 of main scale. Okay, so this is the length in this particular case. Main scale reading plus least count into vernier scale reading. I'll give you the break after some time. Please wait. After we say 20 minutes, I'll give you the break. After 20 minutes, I'll give you the break. Okay, this is how we find the reading in this particular case. Okay, guys, I hope, guys, give me the signal in the chats. Is the vernier caliper crystal and clear to each and every single student? Is this concept crystal and clear to each and every single student? Tell me. Hello? Hello? Great. Now, guys, in a vernier caliber, 8 main scale division coincides with the 10 vernier scale divisions. Like in this vernier caliber, I told you 10 VSD is equal to 9 MSD. This is a one type of vernier caliber. I want to make out another one. I want to make another vernier caliber in which 8 main scale divisions is equal to 10 VSD. Over here, we say 8 MSD is equal to 10 VSD, or we can say 10 VSD is equal to 8 MSD. Okay. In this particular case, and we are supposed to find the least count. Guys, tell me one thing. Can I say 1 VSD in this particular case will be 8 divided by 10 MSD? 8 by 10 MSD? Yes, sir. This is 8 by 10 MSD. Now guys, if this is 8 by 10 MSD, could you please tell me what is the least count in case of vernier caliper? How do we find? We say, sir, that is 1 MSD minus 1 VSD. Recently I told you this is how we find the least count in case of vernier caliper. That is 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. Now you can say over here 1 MSD. This is also 1 mm. 1 MSD is equal to 1 mm minus 1 VSD. 1 VSD is 8 by 10 MSD. Okay. So you can say this is 1 minus 8 divided by 10. Okay. MSD. Guys, MSD means 1 MSD means 1 mm. So this will come out to be, this is 10 minus 8 is 2 by 10, that is 0.2 mm. So it will come out to be 0.2 mm. Because instead of this you write mm and this will come out to be 0.2. So it will be 0.2 mm. So least count of this vernier caliber is 0.2 mm. Similarly, if you have another question of this type, if X vernier scale divisions is equal to Y main scale divisions, here it says that X vernier scale divisions, X VSD is equal to YMSD, where 1 MSD is equal to 1 centimeter. Here it is saying 1 MSD is equal to 1 centimeter, not 1 mm. Keep that thing in your mind. It is mentioned over here. You are supposed to find least count. Guys, tell me, 1 VSD in this case will be how much? 1 VSD will be Y by X, Y divided by X MSD. Okay. Now, if we have to find the least count, so I can say in this particular case, least count will be simply, that is 1 MSD minus 1 VSD. Now, least count in this case will be 1 MSD. 1 MSD is equal to 1 centimeter. 1 centimeter. Okay, forget about it. This will be 1 MSD. Okay. In this particular case, minus 1 VSD. 1 VSD will be Y by X MSD. Y by X MSD. Now do the cross multiply. So this will be X minus Y divided by X MSD. So this will be least count. So can I not say in this particular case, least count will come out to be, that is X minus Y divided by X. Instead of MSD, I would write centimeters. So centimeters over here. X minus Y divided by X centimeters. Great. Not mm. If it was mentioned over here, 1 MSD is equal to 1 mm, then you mention over here mm, not mm. It will be in the cm. Then you have got the next one, that is the scriv gauge. Then you have got the scriv gauge over here. Now guys, let's finish the scriv gauge. See, in this particular case, we need, guys, see. When it comes to the least count of, understand this very carefully. When it comes to the meter scale, its least count is 1 mm. Okay. When it comes to the vernier caliber, okay, its least count is 0.1 mm. If you have something which is less than this, which is smaller than this, how can you measure? You can measure that with the help of the scriv gauge, because this is the lowest measurement that an instrument can take. If you have something less than this, smaller than this, how can you take that? How can you measure that with the help of the scriv gauge? Okay, let me show you how the scriv gauge actually looks like. This is how the scriv gauge actually looks like. Okay. And in this particular case, if you want to measure something, let's suppose we have to measure something. In this particular case, let's suppose we have to measure this rod. We will place it over here. We will place the rod over here. Okay. We will place the rod over here. and it will measure this particular rod. And here it has two scales. You take a look in this case, it has two scales. The first one is called the main scale. That is this. This is the main scale. This one. And then you have got another scale, that circular scale. This is the circular scale. This circular scale in this case is rotating. Like in case of vernier caliper, the vernier scale was scrolling over there, okay? It was moving forward and backward. And when it comes to this here, this circular scale rotates, okay? This is the script gauge. Now, let's come over here. I'll make it over here. This is the main scale, and this is the circular scale over here. This is the circular scale. This is the main scale and this is the circular scale. Now guys, in this particular case, what you are supposed to do is that, okay, we need a more advanced instrument which can measure up to 2 decimal, up to 2 digits after the decimal. How many digits after the decimal? 1, which can measure up to 2 digits after the decimal. It is called script gauge. Now guys, let me make the main scale. And this is 1 mm, 2 mm. Guys. If we take a look at the main scale that we started with, this is the main scale. This is the 1 centimeter. This is 1 mm. This portion is 1 mm, this small portion. Now I am making this 1 mm in a zoomed view in case of the script gauge. I am making this 1 mm in a zoomed view in case of a script gauge. Okay. This is here to here 1 mm, here to here 1 mm, here to here it is 1 mm. Okay. Yes, absolutely clear. It is absolutely clear. Now guys, listen to me very carefully. Since this is the circular scale which we can rotate over here. Guys, see, when we rotate this circular scale on this one, so we are rotating it. And how many divisions are there? Like from here to here, this is 1 mm. How many divisions are in the circular scale? There are total of these divisions. There are total of 100 divisions. We are taking a circular scale in which how many divisions are there? 100 divisions. Like in case of vernier caliper, you said there are 10 divisions, which is equal to the 9 divisions. Similarly, in case of the script gauge, we say there are 100 divisions on the circular scale. Okay. Now guys, when you rotate this circular scale, okay, this, it is basically moving also, like, see. When you rotate the circular scale, this main scale, it will move from here to here. When you basically rotate it by one cycle, when you rotate it by 100 divisions, so it will move from here to here by 1 mm. So it is mentioned exactly over here. When circular scale rotates by 100 divisions, it completes one cycle. In that particular case, the main scale slides by 1 division or 1 mm. So basically, when you rotate this by one cycle, 100 divisions, so this will slide by 1 mm. Like previously, let's suppose the circular scale was here. Now you are rotating. When you have completely rotated by 100 divisions, you will finally find the circular scale over here. Okay, that's how it actually works. If you rotate it, initially it would be here, then finally it would be at 5 if you rotate it by complete one cycle. Now guys, in this particular case, I would want you to understand. Okay, so this is called the pitch, distance traveled by the circular scale in one rotation. Okay, see how many divisions you rotated in case of circular scale? 100 divisions. 100 circular scale divisions. And how much the main scale slided by 1 mm. So 100 CSD circular scale divisions is equal to 1 mm. Can you tell me what is the value of one circular scale division, one CSD? You say, sir, 1 divided by 100, 1 divided by 100, and that is what we call the least count over here, 1 divided by 100. Okay, so this is we say when circular scale rotates by one cycle, that is 100 divisions, main scale moves by, scrolls by, slides by, we can say 1 mm. Okay, so my dear friends, so we say least count, you can say least count is basically pitch. Okay, how much it has slided. Pitch means how much it has slided, main scale has slided, that is 1 mm, that is the pitch, divided by number of circular scale divisions, that is 100. So pitch divided by number of circular scale divisions. So this is pitch means 1 MSD, number of circular scale divisions. This is how we find the least count, and that is in this particular case 0.01. So 0.01. So least count is 0.0. Okay, 0.01. Okay, now the question is, how do we exactly take the reading in this particular case? Guys, is this clear? Please give me the signal over here. Please give me the signal. Is this clear till over here? Guys, give me the signal in the chats. Everyone means whosoever is watching. I hope there is no problem from now onwards in these measuring instruments. If there is a friend of yours saying I am having problem in the units and dimensions, please show them this chapter, okay? Now guys, how to take the reading in case of the script gauge. Okay, see, first check where the circular scale is on the main scale. Note down the reading of the main scale. Now guys, let's suppose you have to first check, what is it saying? First check where the circular scale is on the main scale. Okay, so reading is main scale reading, means. First you have to check where the circular scale is on the main scale. Let's suppose circular scale is present over here at 2 mm. So the reading of main scale will be 2 mm. If we say circular scale is present over here, so we say reading of main scale is 3 mm. That is MSR. Yes. Now, my dear friends, note down its reading. That is main scale reading. Yes, sir, clear. We are able to understand how do we take the reading of the main scale. You have to check at where the circular scale is on the main scale. Let's suppose this circular scale was present at this 5. Then the reading of main scale was 5. If it was present over here at 0, then the reading was 0. So it is somewhere around over here, reading would be something according to the main scale. Now, next is, then check the reading of the circular scale where it is coinciding with the main scale, Now, come over here. Now, guys, see. You have to check the reading of the circular scale. Let's suppose this is not the 0 division over here. This is, let's suppose, 25. So if 25 fifth division is on the reference line, this is the reference line, that's what we say coinciding with the main scale, then the reading of this will be circular. Whatever, let's suppose this division is now over here. When you rotate, it is over here. Then that will be the reading of this. Let me show you over here. Guys. Here, what is, let's suppose this is 6 over here. This 6. Main scale reading in this case is 6. Okay, because this circular scale is present on the main scale at 6. Okay. Then you are rotating. Now, which number of circular scale is present, is coinciding with the main scale? I guess 75. So it is 75. 75 is coinciding with the main scale, or 75 is present on the reference line. I hope this is visible. 75 is present on the reference line, so the reading of the main scale is circular scale is 75. Now, my dear friends, let's take a look. Main scale reading, I told you how do we take it? Plus minus circular scale reading multiplied by least count. This is how we find the reading of the script gauge. Main scale reading, circular scale reading, least count. How do we find the main scale reading? Main scale reading is where the circular scale is present on the main scale. If it is here to 2 mm, if it is here to 3 mm, then you have to check which number, which division of this circular scale is present on the reference line. Done. Multiplied by least count. Least point count is 0.01. There is a question which was asked in NEET 2020. A screw gauge has a least count of 0.01 and there are 50 divisions in its circular scale. This is that circular scale in which divisions are 50. This is that circular scale in which there are 50 divisions. Okay. The pitch of the screw gauges, we have to find the pitch. Tell me, when it comes to the least count, you say, sir, that is pitch divided by number of CSD. Yes, so pitch will be least count multiplied by number of CSD. Okay, pitch will be least count is 0.01 and this is over here 50. Number of CSD is 50 in this particular case. Okay, is this clear? Is this clear? Is this clear? Now we have error analysis. So before this, I'll give you the break. Break will take till break till let's take till 1:15. It'll take us 1 more hour, okay? Okay, okay, okay. Is it fine now? Is it fine now? Is it fine now? Is it fine now? I guess it's fine now. Okay. Now, guys, let's suppose you are measuring the length somewhere. Okay. You are measuring the length somewhere. I'm saying, let's suppose this is the rod. Okay. And length of the rod is, let's suppose, 5 centimeters. Okay. When you measured the length of the rod by any instrument, by the meter scale, whatever it may be, you got the length of the rod as 4 centimeters. But what is the actual reading? Actual length of the rod, that is 5. How much you got? You got 4. Can I say in this particular case, you got an error of 1 centimeter? Yes, because actual should be 5. But you are getting how much? That is 4. So what is the error that you are producing in measuring the length of the rod? That is 1 centimeter. This is what we call the error. And this is what we need to exactly discuss in this particular case. So the first error, that is what we call the absolute error. What does absolute error actually mean? See, it is the difference between the true value and the measured value. It is the difference between the true value and the measured value. That's what we call the absolute error. Like, my dear friends, we say true value minus measured value. That is what we call the delta x. That will be xt minus xm. Let's suppose I can say over here, you have got a rod. You have got a rod. Okay, this is the rod. Okay. You measured the length of the rod. That came out to be 3 meters, 3 mm. And in reality, I am saying, sir, the true length, this is the true value. True length of the rod is 5 mm. This is what we call the measured length. Measured length. You measured and you got this much length. So what will be the error over here? Absolute error. That is delta x will be simply that is true value, that is 5 mm, minus we say measured value, that is 3 mm. Okay. And that will come out to be 2 mm. So error in this particular case came out to be, that is 2 mm. That is 2 mm. Okay. Now, my dear friends, okay, at my place, the prayer timing is 1 o'clock, okay, and it's 1:20 right now. Now, my dear friends, so it is 2 mm. It is 2 mm. So this 2 mm came out to be equal to the absolute error. True value minus measured value. True value minus measured value. Okay. Okay. Let's suppose, my dear friends, we need to talk about one more error. That is what we call the relative error. Absolute is what? True minus measured. Okay. Now we need to talk about the relative error. Guys, see. When it comes to the relative error, I'm taking the two examples over here. The first example is, let's suppose you have got a rod over here. Okay, this is the rod. Okay. And in this case, I'm saying true length of the rod is, let's suppose 5 centimeters. Let's suppose true length of the rod is 5 centimeters. And you got the measured value in this particular case as 4 centimeters. How much will be the error that you are getting? Sir, true minus measured, that will come out to be 1 centimeter. Okay, 1 centimeter. Simply, you have a rod. The true value is 5 centimeter. Measured is 4 centimeter. How much is the error produced? That is delta L is 1 centimeter. Okay. Now, guys, let's suppose you have got a track over here. You have got a road over here. This is a road. Okay. I am saying in this particular case, the length of the road in this case is as 6,400 kilometers. It's a very long road. 6,400 kilometers is the length of the road. Yes. And what I'm saying in this particular case is, sir, you measured the length of the road in this particular case and it came out to be we say this is L true, and L measured came out to be 6399 kilometers. Okay. Measured length came out to be 6399. What will be the absolute error in this particular case? That is 1 mm. 64 minus 6399, that is 1 kilometer. In this case, error in measuring the length of the road is 1 kilometer. In this case, error in measuring the length of the rod is 1 centimeter. I am asking you the question. Could you please tell me, is this error large in the first case or in the second case? Where is the large error? In which case error is large? First or second? Case 1 or case 2? Please let me know in the chats. Case 1 or case 2? In which of the two cases error is large? Case 1 or 2? Case 1 or 2? Tell me, guys. In which of the two cases error is large? Case 1 or 2? Tell me. Everyone means everyone. Case 1 or 2? Here it is. 1 kilometer. In this case, error is 1 kilometer. Here error is just 5 centimeters. Case 1 or 2? Case 1 or 2? Guys, in both of these cases, we say error is large in the case 1. We say error is large in the case 1. In this particular case. Okay. Why? Because here in this case you are getting the 1 centimeter error in 5 centimeter, measuring 5 centimeter. Okay, we say true length is 5 centimeter and you are getting 1 centimeter as error. It's a large error. And here the true value is 6400 kilometer and you are getting the error of 1 kilometer. When you compare this error with the true value, it is very small. When you compare this true value with this error, it is large, it is comparable. So we say in this particular case, we can say over here, error in case 1 is large as compared to case 2. Error in case 1 is large as compared to case 2. Why? Because here true value is 5 and error is 1. Here true value 6400, error is 1. Okay. Now, my dear friends, this is the concept of relative error. Relative error basically tells us how much is the error, okay, made as compared to the true value. Relative error is defined as how much is the error produced as compared to the true value. That is what we call the relative error. So how do we exactly find this relative error? We say it is absolute error divided by true value. How much is the absolute error? How much is the error produced compared to the true value in comparison to the true value? So that's why we say it is absolute error divided by true value. Absolute error is how much? That is delta x divided by true value. Delta x divided by true value. I hope this is crystalline clear. Then comes the percentage error. Percentage error is simply finding the relative error in percentage. Sir, if I say 20% error is there, that is called the percentage error. Simply, whatever is the formula of relative error, multiply it with 100, it will give you the percentage error. It will give you the percentage error. Like example is over here. Guys, see. We have got a road. Same example I am taking. We have got a road. Okay. I am saying true length of the road is 6400 kilometer. And in this particular case, measured length in this case is 6399 kilometers. 6399 kilometers. Okay. Now, my dear friends, what is the error in this case? That is 1 kilometer. Let's find out how much percent error you are getting in this one. Guys, see. When it comes to the percentage error, I would want you guys to focus exactly over here. When it comes to the percentage error, what will you say? Delta x by true value. What is delta x? That is 1. I can say 1 divided by, what is true value over here? That is 64. So I can say 6400. And multiplied by, you say over here, that is 100. So this and this will cancel. So it will be 1 by 64. So it is not even 1%. So error in this particular case is not even 1%, less than 1%, 1 by 64. Now guys, listen to me very carefully. If here in this particular case, guys, if L measured came out to be 1 centimeter, let's find the percentage error. If I say percentage error, what will you say? Delta X divided by delta L divided by L multiplied by 100. This is L true. Now, can I say in this particular case, my dear friends, you can say, what is the value of delta L? I can say that is 1 divided by. What is the value of true? L true, that is 5 multiplied by, we say 100. 100 by 5, that will come out to be 20%. So, error produced in this case is 20%, large error. That's what I was saying. And error produced in this case is less than even 1%. So this is how we define percentage error, absolute error, and relative error. Simply, when it comes to the absolute error, that is delta X, and that is LT minus L measured. When it comes to the relative error, that is absolute divided by true value, XT. When it comes to the percentage, multiply with 100, it will give you the error in percentage. That's it. Please tell me in the chats if this is crystal clear to each and every single student. So take it here. Let me show you this after some time. Okay. Yes. Now guys, let's talk about this. Propagation of error in a mathematical formula. I would want you guys to understand this very carefully. We say, in this particular case, let's suppose you have got a mathematical equation y is equal to a plus b. Okay. In this case, we say a and b are physical quantities. We say a, b, and y are physical quantities. Okay, are physical quantities. And in this particular case, y depends upon a and b. Why is that physical quantity which depends upon a and b? Now guys, can I say in this particular case, if we get the y error in a, if we get the error in b, we will get the error in y. So I can say if error is produced in a and b, then error will be in y. If there is error in a and b, there will be error in y. If there is error in a and b, there will be error in y. If a and b, if there is error in this quantity, let's suppose a is length, b is length plus length, or something else. So in this particular case, if you are getting error in this, in measuring this, means error will be produced in y, because y depends upon a and b. And how do we write the absolute error? Guys, we can say, so absolute error in y. Guys, see. I can say if you are getting error in a, that is delta a. If you are getting error in b, that is delta b, then there will be error in y, delta. Okay, this is how do we find the error. If you are getting error in a, if you're getting error in b, this error will add up and that will be the error in y. Okay, that will be error in y. Now guys, let's find the relative error in y. Relative error in y. Let's find the relative error in y. Guys, how do we find the relative error in y? That is delta y divided by original value of y. That will be delta a plus delta b divided by we say original value of a plus b, original value of a plus b. Even you can find the percentage error also. Percentage error in y. How do you find, sir? Percentage error in y will be delta y divided by y. That will be simply delta a plus delta b divided by a plus b multiplied by 100. As simple as that. What I'm saying is that y is a physical quantity which depends upon a and b. If a changes, y changes. If b changes, y changes. If you get an error in a, if you get error in b, you'll get error in y. Now, how to find the percentage error? How to find the absolute error? Delta a plus delta b is equal to delta y. We say how to find relative error? Delta y by y is equal to delta a plus delta b divided by a plus b. Okay. And here this is percentage multiplied with 100. Let's suppose if you have a physical quantity a minus b. In this particular case, if somebody wants you to find out the error in y, what will you say? You'll say, sir, delta y will be equals to delta a plus delta b. Sir, in this case, why are you adding? Why are you adding? Why are you not subtracting? Because if you are getting error in this, error always adds up. You can't say this error minus this error. Okay. Mistake minus mistake is double mistake. You cannot say you are subtracting the mistake. No. Okay. You always add the error. We always add the error. Okay. This is the way. Always add the errors. Okay. Even if in this case it is minus, it is subtraction over here. Okay. Now guys, in this particular case, I can say, let's find the relative error in y. Relative error in y. This was what? This is absolute error. How do we find relative error in y? That is delta y divided by y is equal delta a plus we say delta b divided by a minus b. Here you need to put the original value of a minus b. Okay, delta a plus delta b upon a minus b. Let's suppose if somebody asks you to find the percentage error also, what will you say? You'll say, sir, percentage error. Okay, or I can say percentage delta y divided by y is equal. That will be delta a plus delta b divided by a minus b and multiplied by, you say, 100. And my dear friends, in this particular case, you can say this is the percentage error in y. This is the percentage error in y. Okay. Next, you have got this one. Y is equal to a multiplied by b. Y is equal to a multiplied by b. If you have a physical quantity, something like this, a multiplied by b, how do you find the error in this particular case? That's what we need to discuss. Percentage error, relative error, and we say percentage relative and percentage relative and we say absolute error over here. Now guys, take a look. In this particular case, I don't have to go with the derivation. Directly, I would say in this particular case, we say first of all, we'll find the absolute error. Absolute error. Guys, understand this very carefully. When it comes to the absolute error, you say, sir, delta y will be equals to. You say, that is this quantity, b delta a. In case of multiplication, this is how we find the percentage error in a. Y. This b multiplied by absolute error of a. Then we say plus. We say this a multiplied by delta b. That is absolute error of b. Okay. Now guys, let's find the relative error. Relative error in y. So that will be delta y divided by y is equal to, here, we can say b delta a divided by original value of y, that is a into b. Then we say plus. We say a delta b divided by a into b. Now tell me, this b and this b will cancel. This a and this a will cancel. So in this case, what we are getting is that is delta y divided by y is equal to delta a divided by a. Then we say plus delta b divided by b. Delta b divided by b. This is what we call the relative error in case of multiplication. This is what we call the relative error in case of multiplication over here. Okay. And if you want to find this in percentage, just simply multiply with the 100, you will get the error in percentage. Okay. Now, in general, if you have got a quantity y is equal to a plus b, in this particular case, we say absolute error is delta a plus delta b. Relative error is this much. Similarly, y is equal to a minus b. Then we say here, absolute error is this, relative error is this. Y is equal to a dot b. Absolute error is this. This is the relative error in this particular case, delta y by y. Okay. And in this particular case, this is the absolute error. You can basically multiply it something. Okay, you can find the absolute error in this particular case, something like this. Multiply this y over here and this will come out to be the answer. Is this clear? Is this clear, guys? Is this clear? Please give me the signal in the chats. Please give me the signal in the chats. Let's suppose if you get a question something like this. If you get a question something like this, give me the signal in the chats if this is crystalline clear. Okay. Y is equal to a raised power n. Y is equal to a raised power n. Guys, in this particular case, if you want to find the error in y, relative error in y. Guys, see, I can say delta y divided by y will be, whenever you have something of this type, of this form, in that case, always remember, take this n down. Then you say delta a divided by a. That's it. Whatever is in the form power, take it down. Let's suppose it's 2. So 2 delta a divided by a. This is how you find it. And when it comes to the percentage, you multiply it with the 100, you will get the percentage error. When it comes to the percentage, you multiply it with the 100, you will get the percentage error. Okay? Yes. If it is something like this, in this particular case, let me show you guys. See. In this case, we say over here, delta y divided by y is equal to, guys, what is power over here? N. Take this n down. N delta a divided by a. Then we say plus, and if this is m, then take this m down, m delta b divided by b. This is how you exactly find out the error in this particular case. Delta y divided by y is equal to n delta a by a plus m delta b by b. If you have the formula or the physical quantity of this form, this is how you find the relative error. If you have something like this, this is how you find the relative error. And when it comes to the percentage, you simply multiply it with the 100. 100. Okay. And if you have, let's suppose, something like this. Here, a constant is multiplied to a physical quantity. If a constant is multiplied with a physical quantity, how do you find the error in A? Relative error in Y. How do you find the relative error in Y? Simply in this case, you say delta y divided by y is equal to, take this constant out. It cannot create anything. It cannot, we say, create any sort of change over here. You simply say ignore this constant. This will be delta a divided by a. Ignore the constant in such case. So you will get this. Okay. I hope this is crystal and clear. Now let's solve the questions on this. First, before this, I will show you, okay, this question. I will show you this question. Okay. Let me show you this particular question. Let's see. If the error in measuring the radius of a sphere is 2%, okay. Guys, understand? Then error in the measurement of the volume is, if we have a sphere, I can just write over here, volume of a sphere. Could you please tell me what is the volume of a sphere? Guys, see. We say volume of a sphere is 4 by 3 pi r cube. Since the question says that, if there is error in measuring the radius of the sphere, if there is error in measuring the radius of a sphere, how much will be the error in volume? Guys, see. Volume depends upon radius. If you produce error in radius, volume error will be in the volume. So we can say V is equal to R cube. Since I told you this constant you need to ignore, it will not create any sort of problem, so you ignore it. Now, don't you think that in this particular case it is of this form? It is of this form. Y is equal to a raised power n. How do we find the error over here? N down delta a by a. And if you find the percentage error, you say, sir, percentage delta y by y will be equals to n delta a by a multiplied by 100. Similarly, I'll have to do the same thing over here. Guys, see. Can I write error in the volume and percentage error we are supposed to find? Percentage delta V divided by V is equal to percentage error in the volume. Then 3 down delta R divided by R multiplied by 100. Yes. Now, delta R by R into 100. What is this? This is the percentage error in the radius of the sphere. That is how much? 2%. So I can say percentage delta V divided by V is equal to, I can say 3 delta R divided by R. Sorry, I can say this is 3 multiplied by, this is 2% over here. This is 2% over here. So I can say in this case is 3 into 2 is 6%. I can say 3 into 2 is 6%. So what is the error in the volume? That is 6% in this particular case. That is 6% in this particular. Let's take a look over here. In an experiment, four quantities, we say A, B, C, D are measured with the percentage error 1%, 2%, 3%, 4%. So basically you are measuring these physical quantities. You are getting error in A as to 1%, error in B as 2%, error in C as 3%, error in D as 4% respectively. And this is the formula. P is equal to A cube 2B, P2, P raised power 2 upon CD. We have to find the error in P. Guys, tell me one thing. We say, what is the formula given? P is equal to, that is A cube B square divided by CD, Tell me one thing, guys. If you have to find the percentage error, guys, delta P divided by P, if you have to find the error in this, this is A raised power 3, B raised power 2. It is A raised power n, n down. Take this 3 down. Then we say delta A by A. This is how we write the error in this A. Then plus. It is A raised power n, B raised power m. Something like this. N down delta A by A. M down delta B by B. Okay. If, guys, here I'll show you one more type. Let's suppose it is in this case A raised power n, B raised power m divided by C divided by D. How do you find error over here? See, delta y divided by y will be, first of all, a raised power n. Okay. First of all, this is n delta a divided by a. Then you say plus m delta b divided by b. Then you say, guys, if you take this c in the numerator, it will become c raised power minus 1. So you can say error in the c will be also added. Guys, even if it is in the denominator, whatever is the error of this, that will be also added. You say delta c divided by c. Then you say plus delta d divided by d. Because, my dear friends, y depends upon a, b, c, d. If you produce error in all the 4 quantities, that error will be added. Even if it is in the subtraction, it is in the division, error will be added. So same is the case I am doing in this particular question. 3 delta a by a. Then we say 2 delta b by b. Then plus error in this, that is delta c by c. Plus error in this, that is delta d divided. Okay. Okay, yes. Now guys, if you find this in the percentage, so you multiply simply over here with 100. This will be percentage. Now tell me, delta a by a into 100, that is percentage error of a, that is given as 1. So this will be 3 into 1%. Okay. Then we say plus 2 into delta b by b into 100, that is given as 2%. Okay. Then we say plus delta c by c into 100, that is percentage error in c, that is 3%. That is 4%. Now guys, 3% plus 4% plus 4% plus 3%, this will come out to be 14%. So error in P will be 14%. Is this clear? Is this clear? Tell me, is this clear? Great. Now take a look over here. A physical quantity is represented by x is equal to, there is a physical quantity, it is x is equal to MA LB T raised power minus C. If the percentage error in the measurements of M, L and T are alpha percent, beta percent, gamma percent, then percentage error in X will be, we have to find the percentage error in X. Guys, how do we find the percentage error in X? So that is percentage delta X by X will be, guys, power of M is A. So I can say A delta M divided by M. Then we say plus power of L is B. So this will be B. Then I say delta L divided by L. Then I can say plus power of T is minus C. So it will be C, power down. I can say delta T divided by T. And if you find this in percentage, so multiply this with 100. You will get this in the percentage. Okay. Now guys, tell me one thing. Can I say in this particular case, guys, this is alpha A. Delta M by M into 100, that is given as alpha percent. So I can say this is alpha. Instead of this, I'll write alpha plus B. Delta L by L into 100 is given as beta percent. So I'll write over here beta. So that is, this is percentage error in L. Then we say C. In case of this T, percentage error is gamma percent. So it will be over here gamma. It will be over here gamma. So this will be A alpha plus B beta plus C gamma. This will be the percentage error in P. This will be the percentage error in XX. This is what we already did. Okay, let's talk about this one. Is error deleted? Error is there, guys. Just a second. Just a second, let me see. Errors is there. Errors is in the NEET, yes. Now take a look. A force F is applied on a square plate of side L. Let's suppose you have got a square plate of side L. Okay, you are applying the force F and its side is L. Whenever you apply the force on a plate, we say pressure is created. Okay. If the percentage error in the determination of L is 2%, okay, and that in force is 4%, I can say delta F divided by F into 100. This is percentage error in force. This is given as 4%. And in this case, delta L divided by L into 100, it is given as 2%. You are supposed, what is the permissible error in the pressure? You are supposed to find delta P by P into 100. This is what you are supposed to calculate. Guys, it is very simple. When it comes to the pressure, we say pressure is force upon area. Okay. And you can say force upon area is a length square, L square, side square. So now percentage error in pressure, that is delta P divided by P, will be equals to percentage error in force, delta F by F, is equal to, take this in the numerator, then we say plus, it will be L raised to power minus 2. So it is 2 delta L divided by L. Okay, into 100 because it's in percentage. So it will be delta F by F into 100. That is given as 4%. Plus 2 into delta L by L into 100. That is given as 2%. 2 into 2 is 4. 4 plus 4 is, we can say, 8%. So it will be 8%. Percentage error in the pressure will be 8%. If the percentage error in the measurement of momentum and mass of an object are 2% and 3% respectively, then the percentage error calculated value of its kinetic energy is, you have to find the percentage error in the kinetic energy. Guys, listen to me very carefully. We say kinetic energy is equal to 1 by 2 mv square. Okay. Kinetic energy is equal to 1 by 2 mv square. Now guys, I would want you guys to multiply and divide. Multiply and divide with m. Multiply and divide with m on both sides. So what will you say? Sir, this kinetic energy, multiply and divide with m. So this kinetic energy will be, not both sides, from this side. So it will become 1 by 2 mv square. M by m, you have to multiply and divide with m by m. So what will it become? M into m will be m square v square divided by 2m. And this is kinetic energy. Now guys, since all of you know that when it comes to the momentum, it is mass into velocity. Okay. Now if it is momentum square, so it is m square v square. Now tell me one thing. Instead of this m square v square, can I write p square? Yes. So kinetic energy will be simply p square divided by 2m. Now take this over here. So kinetic energy, okay, just keep it as it is. Keep it as it is. This is the formula of kinetic energy in terms of momentum. Now guys, now look at the question. It says that percentage error in the measurement of momentum and mass. Error in momentum, error in mass is given. You have to find the error in kinetic energy. It is simple now. Okay, this is the last question of the session. We are done with the session. So now tell me in this particular case, guys, I can say percentage error in kinetic energy delta K divided by K is equal to, tell me, can I write over here 2 delta P divided by P? And this 2 is the constant over here. Ignore this constant. So it will be plus delta M divided by M. Multiply this with 100 because you have to find this in percentage. So what will you do? So this is percentage delta K divided by K is equal to 2 delta P by P. So we'll say over here 2 delta P by P into 100. So error in the momentum is given as 2%. So 2 into, I can say 2%. Then plus error in mass delta M by M into 100 is given as 3%. Okay, so you will say 2 into 2 is 4%, 4 plus 3 is 7%. So it is 7%. So it is 7%. Is this clear? Please tell me in the chats. Everyone. Is this clear? Is this clear? We are done and dusted with the chapter. Guys, I would want, okay. This question we already did, so I'm deleting this. This is your homework. Comment down its answer. So do let me know the answer of this question in the comments down below. And do comment down below and let me know how was the session, okay, once I end the session. So thank you. Next session will be kinematics. I would want you guys to go and smash the like button on that session. That will be day after tomorrow. Okay. So do comment down below later on. Okay, once I end the live stream, do let me know how was the session. Yes, JE students can also watch this particular session. Okay. So that's all for today, ladies and gentlemen. Thank you so much. Take care and bye-bye. See you guys very soon. See you guys tomorrow. So guys, take care and bye-bye. Thank you so much. You guys can leave.